usually found in Saudi Arabia. But definitely not the stephensi that we know right now.
Fredros, if I could just add on to that, there was a published record of stephensi in Egypt in the, I think, 60s or 70s that was later, I guess, corrected. And they, I think Ralph Harbach described it as Anopheles in Shamsi or something like that.
Okay, so the record we have for the 1967 detection of Anopheles venestras in Egypt was corrected. Okay.
Right.
Okay. We will bring up this question in the masterclass today as well. So, and it's nice to have you, Alia. Thank you. Thank you. Thank you. So, as I said earlier, we have quite a bit of interest on this masterclass. 600 registrations. We will today probably have 200 people join on the call. I don't know, maybe more. And I have with me, of course, Nana, my brilliant co-host, and our experts. And today we have a lot of experts, which is good, from different countries as well. And we will see how that is going to go. So in Swahili we say karibuni sana. Most welcome. Most welcome to Tanzania.
Hello, I am Dr. Ghosh from Bangalore, India. Hi, Dr. Seth, Dr. Fitsam. How are you? Dr. Yadav, how are you?
See you.
Very good. Nice to see everybody.
Yes.
Hello, Dr. Ghosh.
Hello, Dr. Yadav. How are you?
All well.
Yeah.
Yeah,
Hi,
so
Dr.
just so you know,
from Bangalore.
Go ahead. Welcome, everybody. We have, I just wanted to say that this masterclass is now streaming live on our YouTube channel. And as usual, I will ask my colleagues at Ifakara Health Institute to share the link to the YouTube channel. Just so that whoever wants to share that with colleagues can do so now or later. May I just ask if my colleague Halfan is on the line? Zawadi?
I don't see them.
Okay.
Hello, Fred.
Yes.
I think Arfan is attending another meeting.
Okay.
They're just finalizing the meeting. You'll join shortly.
All right. Okay.
I just wrote to Zawadi. Let's see.
Is Zawadi there?
I just wrote to her, but
Okay. Yeah, I'm trying to get one of our co-hosts to help admit participants.
yeah.
So that's the reason I'm looking for them. I think we are set to be. Hey, Professor Derek Charlotte, nice to see you. Happy New Year, my friend. You're muted, but whatever you're saying, it's nice to see you, man.
Hello, Fredros.
Hello, how are you?
I'm fine. I'm good. And you?
Very, very good, Lenus. How is Jimna?
Jimma is doing fine. He's doing well.
Excellent.
Happy New Year.
Very good.
Okay. Good.
Yeah, we are doing fantastic.
Before the meeting, then, Fredros, I'll say Happy New Year to you.
Happy New Year. Happy New Year, Derek.
Yes. Can you see where I am?
Are you in Mozambique?
Ngoja.
Is that Derek joining from Mozambique?
That is Derek joining from Mozambique, yes.
Excellent. True entomologist over there.
Hi, Fredros, how are you?
Hey, Quaker. Happy New Year.
Same to you, my friend. How have you been?
Fantastic, fantastic. Nana shared with me your paper on stephensi when we were preparing for the masterclass. Thank you very much.
Ah,
Yes,
thank you.
yes. So I hope you're having a good time over there.
Yeah, for sure. It is good time.
Yes.
Mm.
So, Nana, I guess that we probably have enough people to begin. And so one more time, I'll just check. As a word or Halfan.
There's no response from Zawadi now. And there's someone else though at the back. Oh, I can also keep adding people if it's
Yeah, you can do that. That's fine. If that's, yeah, you can do that, man. Yeah. So with for the respect of Lisa Irish, we will begin the call.
Yeah.
Nana, I believe my screen is visible.
Yep, yes. Presentation mode, super. That's it.
Excellent. So,
Nope, we lost it.
yeah, intentional. Intentional. So, Nana, you give me a go ahead.
Okay, just 1 second, Fedros.
Yeah.
Sorry, I'm calling from South Africa in a place I have never been. So it's just, anyway, good. I'll say, Fedros, let's shoot.
Ladies and gentlemen, we gather here today as experts, policymakers, stakeholders, and students from around the world. We gather here to address a critical issue that threatens the health and well-being of millions of people in our world. I am speaking together with my colleague Nana Williams today of the invasion and spread of Anopheles stephensi, the Asian malaria vector that has made its way into African countries, lately including Kenya, but before that we knew it was in Ethiopia, Somalia, Nigeria, Sudan, several other places. This is not just a local problem, but a global one that requires our immediate attention and action. We must increase our vigilance and scientific investigations into the threat that is posed by this vector. It is important to note that we do not fully understand the biology of this vector yet, especially in the African context. And we also do not know how it will influence malaria burden in the continent overall, especially in urban settings. However, several experts have indicated it may lead to increased burden of malaria and possibly even local transmission in many urban settings. It is important to note that Anopheles stephensi is just one of the many biological threats facing malaria control in Africa. And in countries such as those in the Horn of Africa, we must consider the fact that this adds on to the challenges of drug resistance, failing malaria diagnostics, due to HRP2 gene deletions and the presence of Plasmodium vivax and Plasmodium falciparum co-occurring together. And Nana and myself urge you, our audience, to pay attention to the WHO guidance on urban malaria as well, and the need for integrated systems for disease surveillance. To our colleagues in the affected countries, we want to express our deepest sympathy for the burden that this invasion has placed on your communities. But we also want to commend you for the work that you have already done to combat this threat. Your contributions to the knowledge base on Anopheles stephensi is increasingly invaluable, and we are very grateful. Sincerely, we thank you for these efforts, and we can only imagine the struggles that you and your teams and your communities, of course, will be bearing in the next few months. We would like to pay special attention to our colleagues leading the fight against this vector and against malaria broadly in respective countries. We are joined today by Dr. Fitsum Tedese in Ethiopia and his team, a number of experts from Ethiopia. We have Ayman Ahmed from Sudan. Hopefully he's going to join the call. We have colleagues from Nigeria. Didapo is there. We have our friend Eric Ochomo from Kenya. We have our colleagues from Djibouti, Egypt, and several other countries, and many, many more. We appreciate your tireless efforts, and we just want to congratulate you in the beginning for all this work. I would also like to acknowledge the contributions of our colleagues from PAMCA and our colleagues leading the WHO efforts, our colleagues in other organizations such as USAID, PMI. Your work is essential as well, and I'm also grateful to my colleague and friend, Dr. Nana Abba Williams, who is co-hosting this with me for several episodes now. Lastly, to our experts and policymakers in attendance, we want to thank you, extend our heartfelt gratitude for you for taking time. And we appreciate the knowledge that you bring into this and the experience that you bring into this. We are honored to be in the presence of your brilliant minds. And we are also very encouraged to see a number of postgraduate students joining here today. And thank you so much for that. We would like to thank you all who registered for this. And I just want to say that, like I was saying earlier, we have 600 registrants on the masterclass. We expect a number of them will join live today, maybe up to 200 plus. Your participation shows the importance of this subject and the willingness to work together to find solutions. And I suggest that we should all embrace this going forward. So we're going to start the masterclass now and listen to our colleagues. And Nana, if you just want to admit the rest of the guys who are waiting on the line. I think we have quite a number of guys waiting over there. I'll repost my slides so that we can begin the conversation. On this. Nana, can you confirm?
It's coming up. Not yet.
Not yet?
Good.
Good. Good. Excellent. Excellent. So I think all of us remember this alert that we had from 2009. And the best place for us to begin perhaps is to ask Dr. Seth Irish. Seth, if you just want to provide like a 1-minute update of where we are from 2009 when WHO first made this alert. And before that, I guess many of us already realized that in 2019 when this alert came out, this was, already several years, 7 years after the first publication on Anopheles stephensi in Kenya, so in Africa. So you could argue that was late, but I think that WHO and partners have done an incredible job, putting teams together and tracking this threat in the recent years. So I just want to listen to Seth. Seth, if you don't mind, if you just want to provide a brief update of where we are today in respect to relative to where we were in 2019 when WHO first released this alert.
Sure. I mean, I think the first thing to note is that the list of countries that begins this vector alert in 2019 has now expanded. And so I think Yemen, Kenya, and Nigeria have been added to the list. So there's a clear sign that it's expanding. And I should note that we're hoping to put out a new vector alert. It should be any day now. We're just working it through the administrative channels. And so hopefully that should be out and published very soon. That gives some updates on what we know about stephensi in terms of its biology and how to conduct surveillance and things like that. So hopefully that should be useful. And then if I might just make note of two other activities that WHO is doing with regards to Anopheles stephensi. We have the malaria threats map, where Anopheles stephensi has been incorporated into the other threats maps. Sorry, I have a sick child at home today, so
no problem.
Apologies. So that map shows all the locations where Anopheles stephensi have been found outside of its native range. And we're also recently made a change to show negative findings. So hopefully those will help us to find out not only where Anopheles stephensi has been found, but also where the surveillance has been conducted. And then the other recent WHO initiative is the initiative that was launched in September last year, which was an initiative against the spread of Anopheles stephensi in Africa, with kind of 5 main objectives: information exchange, increasing collaboration, strengthening surveillance, prioritizing research, and developing guidance. And so that has been published. And so I encourage anyone who's interested to take a look at that. And we're also hoping to continue our quarterly calls. So, I mean, I don't think we have as many people on those calls as you have on this one. So it's nice to join this. But we have quarterly calls to give the latest updates on Anopheles stephensi. And we're also having a partners convening in Ethiopia in March this year. So hope to push things forward that way.
Thank you so much. Thank you so much, Seth. And we will be discussing more on the WHO strategy today. We note that one of the components of that is information sharing, and we believe that this masterclass contributes to that as well. So that's great. Let's go back to this discussion we had just before the masterclass began. If you look at this map, this is a recent publication. We found, and I sent an email to the authors for this, but I haven't received a response yet. Hopefully we will. But you see over there, you see the dot 1967 Egypt. You see, it appears that there was an Anopheles stephensi record in Africa in 1967 that's kind of disappeared off the map. So if anybody wants to comment on this, I would like to invite Alia, Dr. Leah Zayed, who is on the call with us, operates in Djibouti and Yemen, to make a comment on this, and maybe Seth, if you want to add as well.
This is like a previous work of kind of a checklist of the species in Egypt in 67 by Dr. Ged. By that time, definitely they should have seen stephensi the same type, the same form as used to be in the Gulf or Saudi Arabia or the other areas, but not the invasive. It hasn't been seen or recorded again in the recent years, in the recent decades, and definitely I'm a kind of not optimistic at all. If we start the surveillance in the southern area of Egypt, I have the gut feeling that we would definitely find some. And of course, having the Anopheles, the invasive Anopheles stephensi in Egypt, knowing how crowded the cities are, that would never be a good sign. But so far, it's just in the history and has never been seen again.
Right. No, thanks a lot for that. And just as matter of acknowledgement. The author of this paper is Dr. Farah Ishtiaq. Dr. Farah Ishtiaq, sorry that we didn't put the link to that, but we will provide a link to this paper for those who want to read. It's a very short article. It's published in Trends in Parasitology, formerly known as the Bull, not the Bull, formerly known as, what was it called before? But what was Trends called before?
Excuse me?
It was called Parasitology Today.
Parasitology Today, yeah. So Trends in Parasitology, this is where this paper is published. And the author is Farid Ishtiaq. So based on what Aliyah was saying, can we say, actually, Bart, let me ask you that, can we say then that this map as we have it now is really an indication of where surveillance is happening as opposed to where stephensi is?
If I may say, is not a current one. We are talking now about the invasive Anopheles stephensi. So definitely we need to revisit the surveillance in Egypt and see if it is really there or not, or has been displaced by other vector during that time.
So Aliyah, what you're saying is that we should distinguish between the invasive stephensi from the indigenous stephensi in Africa?
Yes, because the stephensi, the Anopheles stephensi, has been always there in Saudi Arabia, for instance. And it has never been a threat like the Anopheles arabiensis. But nowadays, there are the Yemen has started, and the dispersal of the Anopheles stephensi is going a little bit up, and maybe will invade Saudi Arabia with another invasive strain. The form that is invasive, not the current, or the past form that used to be in the Gulf or in the area. That's what I'm saying.
Wow, that's interesting. That's very interesting. Do you have any comments from the experts on this?
Excuse me, it's just my comment on that, because it needs a real investigation, real study to see what form do we have in those countries.
Right.
Yep. I think I understand what Aliyah is saying, but I think the use of the word form may be a bit tricky, because Anopheles stephensi has the three forms: type, Mycerensis, and intermediate. And I don't think that's what you're talking about, Aliyah, are you? I think it's more the population genetics, that it's a different population.
I'm talking about both, the type form and the genetic form. I mean, I'm talking about both.
Oh, okay.
Okay, I've just been informed that my slides are not showing properly, so I'll stop and reshare.
Dr. Said, whatever the stephensi we received from India, all from the coastal belt, they are from type forms.
Go ahead, please.
So the question is that how this species has adopted in a course of time. And the Mycerensis was actually described in 1937 by Dr. B.A. Rao and Sinton, before it is near to Bangalore, which is actually that type location. It was described in 1937 by Sweet and Rao. And then it was described that type form Mycerensis, these were all subspecies. Okay, and then it was by Dr. Puri, I.M. Puri in 1947-48. Then Nuttingland, he said no, because there are interbreedings going on between type form and intermediate form. So there should not be, subspecies. And the recent studies now, there is an dispute going on whether it is a sibling species. A study from, I think, from Iran scientists, and they are telling that this is sibling species. But as far my knowledge, sibling species is defined from the basic criteria is they are morphologically similar, reproductively isolated. But in stephensi, it is not. Why? Because they are interbreeding. In Mysorensis and typeform, with interbreed. And there is a paper by our senior scientist from India, Dr. Subbarao, and even Chris Cartesian author in 1987, they described the intermediate form. So the distribution pattern of type form, intermediate form, and Mysorensis form, I think they are well defined. But whatever the histories we are getting from India, all the coastal cities, like you talk Mumbai, you talk Chennai, you talk Vijayawada, you talk Kolkata, which is the peninsular India part, they are all type form. And Chennai also. And even West Coast also, like Cochin. So they're all type form. Even Lakshadweep, I think, type form. So the type form is now well established in the coastal part and in the inner part also in India. And that is the analogy if you take that Mysorensis having in India has got almost no role, rural part. If you talk of Mysorensis in Iran, there is an article by Basiri et al. And they found that Mysorensis also equally can transmit malaria. And I saw an article by thesis that even my stephensi also they have done on knowledge-eye infections. So knowledge-eye also can be, experiment they have done. And the question right now is coming that how efficient has got the vectorial competence and how this genetic barrier is, important in all geographical locations. I think that is the way we need to study further.
All right. Thank you so much. Thank you so much. So I guess that remains a little bit unresolved, but we will follow this up. I'm going to hand this back over to my colleague Nana. Nana, please.
Yep. Okay. So we've, like Pedro said at the beginning, we've seen that the vector now is in Kenya, and recently it's also, well, before Kenya, it went to Nigeria. And we seem to talk a lot about the origin, and perhaps is it so important to talk about the origin or more concentrate on the spread? And I don't know who gave that question to, perhaps to Fitsum here. Should we think of more?
We have Eric and Charles from Kenya.
And Charles, okay.
So Eric and Charles, if any one of you guys want to address the recent detection in Kenya.
Detection in Kenya.
Okay, I'm hoping you can all hear me.
We can, yes. Yes.
Let me say that ours was an exploratory finding. So we have, as you can see on the map, so the map shows the site where we found stephensi, which is up north in Marsabit. But we have had active surveillance mostly in this Turkana area because that area is a little safe. And so we have teams that have worked there for, I want to say, the last 5 years or so, trying to identify stephensi. So far, they have not found anything there. Then for us, this was because there was someone from National Museums who was up there collecting something totally different, but they spotted Anopheles in containers. And so we sent a team out there and they came back with stephensi mosquitoes. One thing I want to mention is, looks like this was all along this northern corridor that connects Kenya and Ethiopia. So it looks like the route of spread is mostly because of tracking routes. So ideally, routes, human movement. And so that's something that we want to try and now factor into additional surveillance going forward. And so there's a bit of work. So there's very little work that has been done on the eastern side. So the areas around Mandera, Wajir, as you can see on the map here. And so those are places that we also want to try and figure out what's going on. Additionally, we want to try and see how far south stephensi has actually traveled. But at the moment, this is all we know. This is actually based off 59 samples collected from level habitats based on these collections here. So that's what we know now. It was all exploratory. So there's probably a lot that we'd know if we did a lot more sampling. And so I think there's a need to strengthen the surveillance there.
Thank you, Eric. And do you have other investigations elsewhere? Or was just this sample that you have in this exploratory search?
So actually, so if you look at that map, the very first map here, we were.
Oh, I think we are losing Eric. Eric, can you hear us? Okay, and maybe I can.
I think we lost Eric. I'm wondering, maybe we have Professor Charles Mbogo on the line.
Yeah. Are we back?
Yeah, we can hear you.
Oh, sorry. So I was just saying that if you look at the very first map here, all of those black dots are areas that we were sampling at the exact same time. So there was actually a very large team from the National Malaria Control Program, so the DNMP here, conducting entomological surveillance. Of course, these were targeted at our traditional Gambia rabiensis fenestas type of habitats. And so there might be a chance that our methodology is the reason we didn't get any stephensi there. But so far, we haven't detected them in any other site.
Thank you, Eric. And then, so before I began, I was saying that many people focus a lot on talking about the origin and then where it's coming from. And then we know that we can see in the map here, the driving to Eritrea and Djibouti on the maps. And then we also see Nigeria. Now we have, but then in Nigeria as well, there's the ocean there, so the airports. So do we have to focus on the origin, or also think more about the spread and the extent to where it is now, and try to gather the evidence that may be causing spreading? I don't know who would like to take that question. And for those who do you think that maybe Seth or?
I just noticed that Sarah was on the line. I don't know, Sarah, if you'd like to give a little talk about the work that you've done with transportation, both maritime and overland.
Yeah, sure. So, hi everyone. That was a great question, and noticing that the first detections in Djibouti and other locations were in seaports, we were wondering if there were any trends looking at maritime cargo traffic into seaports that could help indicate countries that may be at risk. And so to do that, we used the UN trade and commerce data. So looking at commerce that moves through ships between South Asia and the Arabian Peninsula and all of the seaports in Africa, trying to identify if there are any locations that may be at higher risk. And we looked at different time points as well. We looked at the data from 2011, before the detection in Djibouti, 2016 and 2020. And what's really interesting is looking at nothing but the movement of marine cargo alone into ports, identified that Djibouti and Sudan were the two countries at the greatest risk of potential Anopheles stephensi introduction if it's being moved through marine cargo ships. Egypt was quite high up there as well, so just to add that. But that was just looking at the maritime movement. And then we combined those data with the habitat suitability modeling that Marianne Sink has led, and identified locations that may be at risk if stephensi is introduced through the movement of trade and goods. We're also in the process of looking at overland routes, and in Ethiopia, working with some field epidemiologists, residents who are looking at human movement and human movement along borders and across borders.
Yeah, Sarah, while you are on that topic of movement, you guys have done a lot of studies in Ethiopia, trying to trace the exact cause of Anopheles stephensi. And if we got this right, it appears that you're suggesting there are multiple origins. It's not a single entry point. At least from this work in Ethiopia, it appears there are at least two sources, two possible entry points. We see this situation also with studies in Sudan. This is work by our colleagues in Sudan suggesting, again, multiple possible entry routes. So back to the question Nana was asking earlier, I mean, while people are focusing on inversion, there might be also, just local spread between countries, right?
Yeah, absolutely. I think those the genetic data should be taken into consideration, absolutely, and trying to understand if there are multiple introduction routes, where they're coming from, to try to get ahead of the further spread of the species.
Right. We put up here the conclusions from your study in Ethiopia with Tamar. Do you want to say a little bit more about here, and in particular, the assertion that the mosquitoes that come into Ethiopia, if I may use that map to express, are more likely to come from the red zone than to come from the Arabian Peninsula, despite the closeness between Yemen and Eritrea, that the mosquitoes are mostly linked to Southern Asia, that they are linked to Yemen. Do you want to comment on that?
Yeah, I think that was initially quite surprising. So this was led by Tamar Carter's group. And I think it was surprising given the proximity that the species would be more closely related to those in South Asia. But I think this also highlights the need for enhanced understanding of population genetics of Anopheles stephensi. I think we've already heard multiple questions raised on this call about that specifically, and a more thorough understanding of its genetics in countries where it's endemic and invasive will maybe help us to elucidate that a bit further.
Thank you so much. And Anne, our colleague Anne Wilson and Muda, you guys are on the line as well. I don't know if Ayman is on the line too. It would be great to hear from him. This is a particularly interesting observation in Sudan, and here you see that they have laid out a fairly elaborate surveillance system, and they are detecting Anopheles stephensi at the border region. So this is some of this, I believe, are rural areas. You guys can correct us if we're wrong to that. But very interesting that even though countries like Chad, Libya, Egypt have not reported Anopheles stephensi, South Sudan have not reported Anopheles stephensi, but the sampling in Sudan is reporting this at the border regions of these countries. Do you guys want to explain what you think might be happening here? Anne or Muda, if you guys are.
I'm going to let my Sudanese colleague comment on this.
Yeah, I'm not sure if Ayman is with us, but Muda is with us, I'm sure. Dr. Kafi, please.
Hello, how are you?
Very good, how are you?
Everyone? We are very proud to be a part of this. Reality, what we experience here in Sudan, maybe the first time that Anopheles stephensi present in the country is 2018 by one scientist. And after that, we have a collaboration project with Liverpool School of Tropical Medicine. And now maybe we are in the second year of the project implementation. The project mainly, we assess to see what the distribution of Anopheles stephensi in Sudan so far. And at that time, during the development of the project, no data really to base on to select the sites. After that, we use the map produced by Sinca. And according to that, we select like 9 states for this project. These 9 states have 61 sentinel sites out of the site that already Federal Minister of Health allocated for vector surveillance. Because in Sudan since 2014, there are 106 sites for vector surveillance, and 61 sites is included in the project. And we start last July to start entomological surveillance in this 61 site. It's distributed in eastern part of Sudan and the central Sudan and Khartoum, the capital city of Sudan, and the northern part of Sudan that bordering Egypt and Red Sea is a part, other part. We did till now 3 rounds of entomological surveillance using different methods, including CDC light trap and Procovac. In addition to collecting larvae for rearing, after that we identify them. Till now, we find that all these 9 states is positive as Anopheles stephensi both for adult and larvae, but during the collection, the majority we see in the field is larvae. After that, we rear them in the state level. We have insectarists in all this state. We set by the project, and we support the state on training, capacity building of the teams to do the work there. And we have the reference lab in Sinar Research Training Center, Malaria Research Training Center, or all confirmation of Anopheles stephensi will it's done there. Till now, out of this 61 sites, after 3 entomological sites, round 1, round 2, and round 3, both adult and larvae, we find 61 of the sites is positive for Anopheles. 39 is positive site for Anopheles stephensi out of the 61, giving positivity rate of 64%. And also, what we experience in the field, there are a lack of having like adult in the field, but what we consider that maybe there maybe a behavior of resting outside, but in reality, what we see in that, we consider that Anopheles stephensi start to be positive. And our colleague in the IVM department of the Federal Ministry of Health, also they continue doing the routine vector surveillance, and they find out of these 9 states, they have more than another 5 states already positive by Anopheles stephensi. The far areas that bordering Chad, including South Darfur State, West Darfur State, North Darfur State, and even the area bordering South Sudan, also we find Anopheles stephensi. For that reason, maybe we consider that we have diverse of distribution of Anopheles stephensi in the country. And what we're doing now, we will continue this entomological surveillance for more 6 months, 3 months. After that, and now we set to start to assess the quantification of the contribution of Anopheles stephensi in malaria transmission by doing the case control study in 2 sites for for 1 year. And now we set one of the sites to start already this assessment, and we will continue. And every time, I hope we will share the data. And now we're preparing one of the paper for publication. Initially, the distribution, the data coming from the entomological surveillance. Maybe this is what I can give you just an overview. After that, maybe next time we will give something more. Thank you. Over.
Thank you. Thank you so much. Thank you, Muda. And just a quick apology here for all our participants. We just realized that our Zoom facility is at capacity. And I thought we were able to do up to 500 participants, but look like we are at capacity. So there are a few people who are unable to join, except if others get out also. So I'm going to request my colleague Satifakara to again share the YouTube link, just in case some people want to share that with their friends who are trying to join and cannot join. Thank you guys so much. Nana, please, back to you.
Okay, I can see some people are asking questions on detection to Eric, and we have a section on surveillance. And when we get there, perhaps we can talk a little bit about detection in Kenya and elsewhere as well. And it'd be good if people can also communicate later on in sharing how they got about it. Okay, so now this slide's on a deep dive. This is work that is typically done by MESA. Well, what we typically do is to gather information and share it. So in this sense, we performed a deep dive, which is a synthesis of actually what's going on, not on published information, but what research is ongoing. Research in there includes operational research and also implementation science. So on this particular deep dive on Anopheles stephensi, we tried to describe the geographic scale and scope of ongoing research on this topic, on this vector. And we wanted to find the overview of the distribution of the vector and surveillance and monitoring programs, and describe the funding sources for the project, and also list the questions that were being evaluated in those research projects, and to identify and draw if there were overlaps between urban malaria and Anopheles stephensi spread. Okay, so this landscape overview of research and investment It highlights the current evidence base and quantifies the funding. And it's the base for which we can take can identify critical research and funding gaps. The main highlights here, you see, we found after quite a lot of search, we came across 60 projects, and we categorized them into 8 different themes and found 24 funding sources. So the methods for doing these things are it's a systematic collection and curation of information. And then the main areas we find were 15 projects on transmission, blocking and dynamics, 13 on vaccine production, 12 on gene modification, 10 on surveillance, 9 on invasive species, 2 on drug production, and 2 on insecticides. So it was quite interesting to find these things and also for people to see what's happening in that area. And the total of $66.1 million is actually being used in Anopheles stephensi research, of which a whopping amount was funded by the NIH Institute. So the main highlights here really, apart from what I've already mentioned, that we also noticed is that there was only the Ethiopian NMEP and the NMCP from Yemen that were involved in the deep dive that we found. And of all of them, only 14 projects are actually active. So it is important for us to track what's actually happening. It provides all of us information of who is doing what. And then to create synergies, especially in a theme like this that is a threat, and it's not just the only threat that we have in the big malaria problem that we have now, it's one of the multiple threats. So sharing amongst ourselves what we're doing so people know, and then we can collaborate amongst ourselves. That is also very good. Like in the initiative from WHO, one of the points Seth Irish mentioned is that is information sharing. So Fredros, over to you.
Thank you so much, Nana, and great job by Mesa here. I want to follow up on that question with a question to Professor Abraham Zava, who is joining us from in his personal capacity, but also, of course, a representative staff of ALMA, Africa Leaders Malaria Alliance. Abraham, I believe you're still with us, are you? Hello. Hey, Abraham.
Yes, I am. Sorry.
Excellent.
I'm struggling with my unmute button.
Yes, Abraham, Nana just said there's $66 million in financing for Anopheles stephensi research. I know that one of your concerns has been that as much as Anopheles stephensi is a challenge, a problem in Africa, that you would wish that the response to it is much more integrated, and that we do not forget, number one, the other malaria vectors, and number two, that we do not forget the other biological threats that are also in these countries, notably drug resistance, insecticide resistance, and failing RDTs. And in fact, in some countries, mostly in the Horn of Africa, you see that they have all these things co-occurring in a place where they also have P. vivax and P. malaria. Abraham, talk to us a little bit about your position on this and why you are championing the idea of integrated and more holistic responses to Anopheles stephensi.
Thank you so much, Fredros, and thank you so much for the report from Sudan. Sudan is my second home, and I'm so pleased to hear from Hamoda. Hamoda, you are doing a great job, and thank you so much. Yes, I think we have said over and over again about the importance of making sure that while indeed stephensi could be a threat and there are so many unknowns, I think it's important, one, that those who give resources are not really driven or excited about stephensi alone, but also making sure that capacity for programs in terms of carrying out the surveillance for vectors is done broadly, and it does not stop with Anopheles stephensi surveillance. So, and again, I'm sorry to say this because if it's done holistically, if it's integrated, I believe it will also be involving control programs. I was hearing from my friend Hamoda that they're working closely with programs. I think this is the way to go. But if resources are being mobilized out of excitement, because this is a threat, and therefore ignoring other important issues, I don't think we are doing a lot of justice in this particular problem. I'm sure, Fredros, you are aware of the publication by Russell and others, where they assess the capacity of programs in terms of entomological surveillance. It's very weak. And if we don't take the opportunity of working around the receiving side to support also the capacity of programs to do this routinely and not seeing it as a research project, I think we'll be missing the point. I don't think I have missed this, but I'm encouraging those who are mobilizing resources to also look into this. I want to acknowledge, I think it was Sarah, when she spoke about the relationship between the reports on stephensi and maritime data. I think it answers the question that Nana asked. Are we focusing on the spread or where this vector species originated? I don't think it's we'll be wasting our, well, sorry to say this, but we might be wasting our time focusing on the origin. I think we should be focusing on the spread, because by focusing on the spread, then we will really be building the capacity that programs need to make sure that they come up with mitigation strategies to not necessarily to prevent the spread of this disease, but also to making sure that the appropriate interventions are in place, especially noting that most of our interventions, and this is WHO has said it very well, most of our interventions do focus on adult mosquito control, and yet in most of the places where stephensi breed, it breeds with, in water containers most of the time, and none of the programs are actually doing a lot of larval source management, which would have been really ideal to control stephensi. I think it was about a month ago, Jessica, I'm not sure if Jessica is online, Jessica Rockwood, she did ask a very, very good question in Nairobi during the orientation meeting for the Global Fund. The Global Fund is encouraging programs to include in their concept notes, in their funding requests, surveillance on stephensi, and of course broadly for malaria vectors. She asked this question: if they find that they have stephensi, can they use Global Fund resources to do larval source management, which would be really the most appropriate interventions in those settings? I don't remember if this was answered very well, but I think it's a pertinent question that all of us engaged into this activity do also take into account. Yes, collecting this information, then what next? Thank you so much, Fredros. I think I've taken a lot of the time because I'm rushing to another call. But if I come back, then I'm sure I'll be able to contribute further. Thank you so much for the opportunity.
Excellent. Thank you so much for taking your time to provide the suggestions and also for trying to get people back on track. Don't lose focus on the other vectors and work with the NMCPs directly. And it's nice to see those engagements with the financing partners as well. I'm wondering whether our colleagues from Ethiopia, Fitsum or Drenasto, if you guys have any comments specifically on the geographical coincidence of stephensi and the other biological threats.
Fitsum, do you like to go first, or?
Just one of you. Carry on, and I'll go next.
Thank you.
Okay, thank you. Thank you, Fedros. Actually, right now, we are working on Anopheles stephensi surveillance under the controlling emergence Anopheles stephensi in Ethiopia and Sudan project funded by Wellcome Trust in collaboration with the Liverpool team. We have we have been conducting surveillance, Anopheles stephensi surveillance in 26 sites across Ethiopia. And as you know, the Vector Link had been conducting surveillance on stephensi since 2018 and found several sites positive for Anopheles stephensi larvae and adults, especially in eastern, northeastern, and also central Ethiopia. Right now, with our project, we have also identified some more new positive sites for stephensi. We are now actually characterizing the behavior of stephensi and also the biology of stephensi. And we have actually planning to do a case control study to see the contribution of stephensi in malaria transmission in both positive areas. And on top of this, we are also trying to see the contribution of stephensi to malaria transmission in the presence of other native vectors, because we have been collecting other vectors, other native vector species together with stephensi from the some of the positive sites. And we are also trying to see actually the contribution of this exotic invasive species to malaria transmission in those settings where it co-occurs with native species. So we are also actually trying to explore the route of invasion, whether it had multiple or single route of invasion from actually either from the Southeast Asia or from the Gulf. That is also part of our actually activity. And on top of
so
this,
we have a number of questions in line with the around the contribution of stephensi to transmission. So if you just hold your thoughts, we could come back to that, and so that we just go to the next one and then we come back to that. Is that okay, Prof?
Yeah, thank you very much.
So we can discuss that in a lot more detail on the contribution for stephensi. Nana, do you want to?
Yeah, I can take the next one. Okay, excellent. So yeah, as you can see, we've prepared this in clusters, and the next one we're moving on to the biology of the vector. And we'd like to kindly ask Raj Yadav, pardon me if I haven't pronounced it properly, to describe briefly the biology of Anopheles stephensi to the ones who do not know much about it. Raj, should you do that, please? Thank
you, Nana. So stephensi is a well-established species in the Indian subcontinent, and particularly in India, where I worked for almost more than 2 decades. Stephensi is largely breeding in urban settings in containers, which includes overhead tanks in big cities, as well as all household water collections that are not securely sealed for entry of mosquitoes. But stephensi can also breed in small collections of fresh water, garden tanks or fountain pools, or even rooftops collecting rainwater during the rainy season, or at construction sites where people store water for curing bricks and other materials for construction. So stephensi find a small amount of fresh water, and they breed profusely in those situations. We have seen that in the rural setting in India, stephensi was also found very frequently in wells. Wells, I mean, not very deep wells, but wells which people use to draw water, for drinking or irrigation purpose. But we also found a small percentage of stephensi emerging from larval collections from riverside pools and canal seepages, even the rainwater collections, pools in quarry pits collecting rainwater, or in dam side pools. So a number of those situations in rural areas, stephensi exploited those situations, but of course their number is less. Now, what is important that in the dry season, when the water dries up in most of the part of that season, the stephensi recede into more permanent water bodies like wells and ponds. And as soon as rains arrive, they come out again and then populate in those large number of pools or places that are found all around those permanent water bodies. In the northern part of India, which is Punjab province, stephensi was occurring around 1920s to 40s, 50s, and it was wiped out at some stage because of the introduction of irrigated wheat cultivation, which did not need actually water. But in the past 3-4 decades, it has reappeared in those areas because the irrigation fields, farmers started collecting. First, they will pump out water into cemented tanks, and then from those tanks, the water will go into the fields, and those tanks became the permanent breeding grounds of stephensi. Also, because of the farmers who are rich because of high agricultural yield, they started building various designs of overhead tanks, starting from aeroplane design or ducks, or all sorts of very nice designs of overhead tanks. One would be fancy to look at, and those became permanent breeding grounds of Anopheles stephensi. As a result, malaria is slowly entering into those areas, of course, at a very low endemic level. So this is basically the biology. In one of the chats, I also mentioned that in India, we have found 3 forms. The type form is more predominant in cities, and the mycorrhizal and intermediate forms are less frequent in city areas. But in the rural area, we have found all 3 sites, and particularly because in many parts of the country, because of the supply of drinking water in villages, people have started storing water in households, and these species have therefore gradually entered in the rural areas. As a result, we do find type form, but also mostly mycorrhizal and intermediate forms. Mycorrhizal actually in Iran was also implicated for malaria transmission. So therefore, my colleague Dr. Ghosh, who worked in National Institute of Malaria Research, he has said that these 3 species can interbreed, which means that the differences between them are very minor. It is based on the count of egg ridges in different species. So more than 17 ridges would be a type form, somewhere between 15 to 17 would be intermediate form, and less than 12 will be mycorrhizal form. So these differences are so small, and nobody has really did any studies to see what is the sensitivity of these different forms to the parasite development in their bodies. So this is broadly the ecology of stephensi. Largely, this is a zoophilic species, but it can bite human beings if cattle are not around. And it is a predominantly endophilic species, very hardy. We have recently published a WHO guidance on insecticide discriminating concentrations. So I take this opportunity to also inform you that we have now listed the insecticide impregnated papers for monitoring resistance in Anopheles stephensi in different parts based on a multi-center study. Over to you.
Thank you very much, Dr. Raj. This seems to be like some kind of super vector. Can you tell us as well a little bit more on, even, for example, in the dry season, does it still continue to do its work?
Oh, yes, excellently. In fact, in the western part of India, which is a desert, if you know of Thar Desert, in those areas, stephensi breeds in deep wells, So whereas outside temperature during the daytime, maybe 50 degrees, 55 degrees Celsius, nothing would survive. But inside the wells, the humidity is excellent and the temperature is between 25 to 30 or 32 degrees Celsius. So the stephensi breed and rest during daytime in those deep wells. And during nighttime, when temperature outside drops to almost 5 degrees, 10 degrees, they come out and bite people all around those wells. So transmission sets in those settings. So it is like that it depends on the resting places and breeding places found around the human habitations. And as a result, many places in many villages in the western part where people have constructed, they call it tankas. That means the cemented tanks or underground cemented tanks where stephensi breeds extensively and continues to be a vector even during the non-rainy season.
Thank you.
Thank you so much, Raj. Thank you so much. Looks like we have a very urgent question or comment from Rosemary. Rosemary, you can unmute yourself.
Fedrusi, good afternoon.
Good afternoon.
So this is Charles, but I'm using Rosemary's laptop.
All right, Charles.
Yeah, because I tried to join, but it seems we have reached the maximum number of participants.
You're trying to trick me because you know I admit only females into the call.
Okay, yeah. So my question is, I wanted to know what are the drivers that lead to spread of Anopheles stephensi in Africa? Have we able to document that?
Yeah, so why don't we ask Fitsum to take this question, and then he can follow up with his question as well. Fitsum, do you want to respond to Charles? Charles is, by the way, the vector control officer for the National Malaria Control Program in Tanzania. Thank you so much, Charles, for joining us.
Sorry, Fredros, can you repeat the question? I was like
Charles was asking.
Yeah. Okay.
No,
yeah.
Charles was asking what are the key drivers of the spread?
Spread in Africa.
Yes. But then I noticed you wanted to comment on something as well. So maybe you respond to that and then take your question.
Yeah. So if I'm able to answer that question, then we eliminate this mosquito from Africa. Okay, so the comment I wanted to, I had like earlier, the reason I raised my hand was just to supplement the information Rajpal shared earlier on the plasticity of this mosquito. So let's not, always like trying to send this information. Let's not please associate this mosquito only with container breeding characteristic. It has a huge plasticity in its behavior. And if you count the number of labs in Europe and the US, which have like mosquitoes for experiments, the easy one to adapt is Anopheles stephensi because of its plasticity. So in Ethiopia, we find it in urban settings, in rural settings, in containers, small as like water, like bottles, and as huge as overhead containers. So clean water and no nutrition in there. And you also find it in river beds in natural aquatic habitats. So it has huge plasticity. So it gives a wrong message when we always like tend to speak that this is only a container breeder. It prefers, it has a potential to breeding, to use containers, but it's not only a container breeding mosquito. Okay, back to the question. So we don't have a complete answer for that. And then Sarah and others were also mentioning this. So we only have hypotheses. So we only based our observations in the early days on the major transportation corridors from the port to like the central parts of the countries, like for example, if we take Ethiopia. So maybe we need to look into other routes, including livestock market route, people movement, migration, the porous borders across like the artificial political borders across countries. So it's very difficult to answer this question. We need more. Thank you.
No problem. We will follow this more in detail. Charles, just stay with us. I'm sure additional answers will come in. we go forward. I want to follow up a little bit with our experts here on the call about the question of blood feeding behavior. So this is a publication from 2004 where you describe here, there's a description here of the human blood indices, and you see there that Anopheles stephensi has actually a very, very low levels of blood feeding. So Anopheles stephensi is 0.03 human blood index. Anopheles arabiensis, Anopheles gambi, Anopheles funescens, very high anthropophagy or human blood indices there. And that seems to be related to the intensity of malaria transmission, as you see in the map here produced by Dr. Jerry, suggesting that Afrotropical malaria vectors tend to have higher human blood indices and therefore are also very, very much better malaria vectors than elsewhere. Now, Fitzum, in your study, you have demonstrated, and I know that this type of yours is sometimes misunderstood, but you've demonstrated that both Anopheles stephensi and Anopheles arabiensis are very good at picking up the vectors, even though Anopheles stephensi is mostly an animal biting mosquito. Can you explain what these studies mean in terms of the importance of Anopheles stephensi to malaria transmission?
So specifically, this study, the study from which the figures are picked from, has been done using membrane feeding assays. So what we did in these experiments was we used freshly collected patient blood and we used larvae and pupae of Anopheles stephensi collected from the field and raised to adults in the lab. And then these Anopheles stephensi mosquitoes raised from the field were fed the patient blood, the fresh patient blood, in parallel with colony maintained Anopheles arabiensis mosquitoes. So in these studies, we have seen that Anopheles stephensi was more competent in supporting parasite development within its body, including the oocyst stage and the sporozoite stage. So the proportion of infected mosquitoes and the density oocyst and sporozoite load was really higher in Anopheles stephensi than in Anopheles arabiensis. Anopheles arabiensis is a major vector in Ethiopia. And we used mainly Plasmodium vivax in this study. The major reason is because with the improved case management in Ethiopia, when Plasmodium falciparum patients come to the clinic, they often don't have gametocytes in their blood because gametocyte production for falciparum takes 10 to 12 days for the parallel population of the asexual stage. But for Plasmodium vivax, gametocyte production happens within 2 to 3 days. So most of the patients that come to the clinic with Plasmodium vivax asexual stage parasites have gametocytes. So transmission work is easier with vivax. That was why we focused on vivax. But we had also a few falciparum infections, but it was not enough to make a conclusion. But based on the vivax observation, Anopheles stephensi was really a stronger mosquito to support transmission.
Do you know if there are any groups doing these studies with the Plasmodium falciparum?
Okay, maybe that would be your next question. So we have done the case control study, the most recent one, in a natural setting. Because I'm going to talk about like your next topic, Fredros.
Okay,
we can wait.
We can wait. We can wait.
Yes.
We can wait. Thank you so much. Thank you so much for that. Let's proceed.
Hello, Federos. Yes. Can I reflect something on this?
Correct. Please go ahead.
Yeah. So just that was really an important information from Fitzum's team. But we need to, in order to say about the real competence, vector competence between arabiensis and stephensi, we need to again generate data from multiple populations, even from Ethiopia, because just that is one population, just from one site or some sites. But really, since we have now multiple sites where we have multiple populations, it will be good, of course. We'll do it in collaboration, but it will be very informative if we generate data to say, to compare the competence of these two species from data generated from multiple populations. Thank you very much.
Thank you so much. And I think we just want to follow up this and by saying that projects such as SEAS, do you guys say SEAS? SEAS? the project you guys SEAS, yeah. So projects such as SEAS and the work that is being done in Addis, all these are super important. And I'm hopeful that Eric Ochomo and the team in Kenya are going to start additional studies as well on this in Kenya to answer that. In line with that conversation, why don't we move forward then and talk about the vectorial capacity and malaria burden, because this has been a major issue as well. And here, depending on the availability of Seth and our other experts, it would be nice to hear from them as well. I'm not sure I hope that Professor Charles Mbogo has joined too, and I hope that Bart is still with us as well here. So let me just connect my charger here. Yeah, so the main concern here, or the main question here, has been this graph from Djibouti. And Seth, if you're still with us, I would like to invite you to get back onto this. So this data is used very often to suggest that Anopheles stephensi is likely to cause major outbreaks or to result in increases in malaria burden in several locations. And I don't know if our colleagues from Djibouti and also from WHO want to talk a little bit more about the robustness of this information and whether this is actually conclusive evidence that Anopheles stephensi is the major cause of this increment. Seth, are you still there? Or Dr. Zaid? Dr. Leah, are you still there? Or Seth? Yes, please. Hello?
Hello? Or if Seth is there, he could.
If Seth is there, that's fine. Or Sarah Zodi, are you there?
Sarah as well, yeah.
Yeah.
If there's enough evidence that stephensi is contributing to the burden of malaria in these countries.
Frederick, I could maybe comment on it.
Oh, Anne.
Go ahead.
I'm sorry, I'm on a lunch mission here. Anyway, all these figures from Djibouti are really worrying because there's been an increase in cases, but I think we need to be careful to be attributing these increases to stephensi, because there's lots of other things might be going on. There might be coverage issues, there might be resistance, there might be behavior, there might be a lot of other things going on, and I think we need to be careful just because cases have gone up and we found stephensi around the same time to attribute this to stephensi. That's my, yeah. I think we just need to be cautious.
Yeah, so we don't have the evidence to say that.
Right.
Go ahead, Frederick.
No, so we see this in the WHO report, but we also see it in an old publication from Djibouti, where they used a separate set of data. So this, I think, is from the French Army officers stationed there, and they also show this increment there. And in the WHO initiative, this data is actually used. I mean, this is like only a 4-page document, and this data is quite conspicuous on it. So maybe Raj or Seth or anybody, if you guys want to comment on this. We do notice, and we're going to talk about this later, that some of the modeling work, such as the work that is done out of Imperial College, suggests that even if that this, whatever the situation is, it should raise an alarm anyway. But it would be nice to hear from you guys. What do you think? I mean, are we over-attributing, or is this a clear evidence that Anopheles stephensi is causing these outbreaks?
Hi, Frederick. I'm sorry, I was out of connection.
No
but
problem.
I saw, but I did not hear. Actually, currently, the surveillance efforts did not show any other vector but the Anopheles stephensi in Djibouti since at least when we started the surveillance since 2019. We started another surveillance on base, on the US base in Djibouti, which is actually in the middle of Djibouti city, from 2018. And that showed the same. There is no other vector inside there. Every now and then we find one or two Anopheles sargenti, one or two Anopheles faroensis. This was maybe one time, but made on with Anopheles stephensi since then. And the numbers are increasing. And also there is like a pattern. At first, we saw the Anopheles stephensi has like a kind of seasonal pattern. In the recent years, we lost this seasonal pattern. They are all the year round. Whether we can link the cases with the Anopheles stephensi collected, definitely we are trying to do this by testing the females and trying to find out whether they are infectious or not. But at least we could link that geographically. From the spot we have the Anopheles stephensi, there was malaria case report.
That's interesting. 2 points you raised there earlier. One is that you've lost the seasonality associated with Anopheles stephensi, meaning it's all year round. And Nana was asking this question earlier to Raj. And we actually did see a comment here. I believe this is from Ayman, that the simple fact that it lays eggs on storage containers means you have it throughout the year, indoors and outdoors, and it could make it a fairly difficult one to deal with. But the second point you raise is that you're not finding any other vectors. What are your responses then to the comment by Ann Wilson, who is suggesting it could be the actual increases in cases might be associated with just weaknesses in the control program? Is that a case here?
Would you please repeat the last two sentences because I lost connection here? Sorry.
No, Anne mentioned earlier that there might be several other things happening. You know, for example, do we have optimal coverage with interventions? Are they working as desired? So, of course, we understand the point that there is no other vector being detected there. What are your comments to a possibility? And I see Anne is back here just in case I'm misquoting her. But what are your responses to the possibility that the increased number of cases here is much more, it's also associated with just weaknesses in the control programs? Dr. Zayed, can you hear?
Yes, I hear some of, I can guess what you're saying. Definitely there could be, the reason could be the coverage. Yes, of course. But as I said, we have been working on the US base as well to have like a kind of contained area, a kind of area that we can monitor quite well. And that's what we have seen. The same pattern applies to Djibouti city as well. There are other partners who are working in Djibouti, maybe on the call here, they can have their input. But in terms of coverage, what do you mean? You mean coverage like strategic surveillance?
And do you want to come back in and
yeah, I was just going to say that there's a potential other things going on: coverage, population movement, changes in case reporting over time, access to diagnostics. I don't know, I'm not saying there's deficiencies in control, I'm not saying that at all, but I'm just saying with this type of data, there might be other things going on leading to what we see with routine data versus Stephen's eye surveillance is a link. That was my question.
Absolutely, because you may know, of course, that if we are talking about source reduction, larval source reduction, it is impossible in a country like Djibouti. It is not possible even in many other countries. So there are multiple factors. I think I lost you. Do you hear me?
No,
we do.
Okay. Yeah. Yeah, there are multiple factors, the control measures, the resistance by all means, and the recent work that we have been doing showed that the stephensi is resistant to all 4 groups of insecticides. So as well, we used to see in the earlier years, maybe in like a decade from now, other vectors, other malaria vectors, but now we don't see them anymore. We do not collect them anymore. So I think the stephensi is just displacing others and being the dominant one. But in terms of the control measures or the interventions, there are definitely reasons, of course, behind that.
Thank you guys so much. Nana, please proceed.
Okay, I think this here is the outbreak in Ethiopia that's linked to the invasion of Anopheles stephensi. Fitsum, I think this goes directly to you. Can you tell us the situation in Ethiopia?
Thank you, Nana. So this goes along with the previous discussion and also the great comments we have been reading in the chat box. So I would say we had ecological linkage between the increase in case and the presence of the mosquito, at least, right? So Tom made like a nice comment at the end. Until we prove this is not the case, it's good to be more cautious and then start doing something, right? Rather than like trying to find that a reason that stephensi is not contributing. So we're seeing that stephensi is like the predominating mosquito. So there is a city between Djibouti port and Addis. Addis is in the center of Ethiopia, and that city is called Dredwa. It's a transportation hub between the two. So it's a major transit place for the goods, the cargo, and everything. And this was also one of the first cities where Anopheles stephensi was reported in Ethiopia. So last year, just this time of the year, January, February, which is supposed to be like the very dry months of the year, and then you don't expect like the native mosquitoes to survive and then continue the parasite reservoir, maintaining the parasite reservoir. There was an increase in case in that city, and the increase was from 27 cases of malaria during week 2 of WHO to 260 cases in week 5. So within 3 weeks, there was like close to tenfold increase in case. So following the discussions with all stakeholders, we started doing an investigation in there on what caused the increase, the upsurge in malaria. Then we have done a case control study in Dredwa last year, immediately after the report. So we started end of March, and then the study ended in June. And what we have seen, we followed patients at a health center called Goro in the city, and also in a university campus. So in the Ethiopian system, university students live within a campus. So there is a university in one side of the city, and most of the malaria cases were being reported from the university and also this other clinic from the city. So we followed patients who came to the clinic, and also we followed non-malaria patients as controls who also attended the same clinic as controls. and we screened their family members. And we also looked for adult mosquitoes, indoor, outdoor, and larvae aquatic habitats within 100-meter radius of all the households. So the evidence we have seen was that there is association between the presence of the case and the presence of aquatic habitats, and also adult resting sites for Anopheles stephensi in that city. So it was reported last year at the STMH. So there was association between increase in case or presence of case and presence of mosquito, the adult and the immature stage.
Thank you very much, Fitzgerald. I think that was very, very succinct.
Nana, we lost you. Can you hear Nana? Or did you lose me? Fitzum, can you hear me?
Yes, I can hear you, Fred.
Looks like we lost Nana. Professor Abraham, do you want to comment on this as well?
Sure, please. Thank you so much, Fredros. I appreciate the contribution from my brother from Ethiopia about this relationship, but looking at the World Malaria Report, the recent one, for example, I think cases have been increasing in most of the places, and I don't believe in all those places we do also have stephensi. So my point here is, while stephensi could potentially contribute to increased malaria cases, I think we need to be very careful on how we correlate the increase in cases with the presence of stephensi. Personally, I believe countries are, despite the huge resources that go to countries in terms of implementing interventions, there are so many challenges of, health system challenges that might contribute to failing in achieving what those interventions that were intended for. So my wisdom here would be, we might need to look at case by case and not, giving a general correlation between increasing cases with the presence of stephensi. Take the example of Djibouti. We all are aware that this is a country that has been struggling to implement some of the basic interventions, distributing beds, or even spraying sometimes very late and not at high coverage. The local teams, I'm talking about the control programs, are not even able to do a proper entomological surveillance, and yet you expect them to deliver the key interventions optimally. I doubt it very much. So I think let us be careful in terms of how we generalize or we correlate the increasing cases in the presence of stephensi. Over to you. Thank you.
Thank you very much, Abraham.
Yeah, it's a Djibouti National Malaria Control Program.
Thank you.
Can I comment here?
Alia's hand is up.
Yes. I thank Abraham for this comment. Now, moving a little bit from Djibouti, yes, Djibouti was struggling to eliminate malaria, but we started working in Yemen, knowing that Yemen is struggling, of course. The malaria cases are high by all means. But since we started then, we found that the Anopheles stephensi spread as well. Together with the Anopheles arabiensis. Yes, there was a kind of displacement, a kind of the Anopheles arabiensis decreases in areas, while the Anopheles stephensi is increasing in those areas, maybe due to competition or displacement or whatever. But now we are trying to look into the fact whether the cases are really related to the Anopheles stephensi increase or the whole sum of the malaria vectors. This, I think, would help us know whether the Anopheles stephensi would play really a big role in increasing the malaria cases in a country like Yemen. Thank you.
Elena Shao, I don't know if I'm pronouncing it properly.
Yes. Just to comment on the Djibouti's report, to reflect just on the Djibouti's report.
While Denelsa is speaking, sorry for interrupting. I'm also just wondering whether we actually, in case we have an NMCP person from Djibouti or any other partners working there alongside Dr. Leah, it would be nice to hear your voices as well. We are just speaking about Djibouti from outside. It would be nice to hear if we have any partners from Djibouti as well. Just let us know and we invite you right in. Back to you, Delena.
Okay, so shall I continue or shall I stop?
Yes, go ahead.
Please continue.
Okay. So, okay, thank you very much. So you see, I think we need to be very careful. So I don't know whether there were other native species, native malaria vector species in Djibouti before the invasion of or colonization of Anopheles stephensi in Djibouti. The reason is, I don't know how often surveillance was there in Djibouti. Was it weekly, bi-weekly, or monthly, or biannually, or annually? Because my concern is, if you say that Anopheles stephensi was the sole vector for that outbreak, or for the outbreak of malaria, I think we have to be sure that we need to make sure that the non-existence of other native vector species. Otherwise, it will be, how can we just attribute the observed outbreak for Anopheles stephensi? So we need to, because this happens in Ethiopia. In Ethiopia, in some of our sites, our surveillance sites, really there were no other native vector species like Arabiansis, especially the principal vector species in some of the sites. And we were almost to conclude that Anopheles stephensi was occurring alone in those sites. But when you just continue surveillance, the others come up, the other vector species come up, including Arabiansis. So it will be it's difficult to attribute maybe the outbreak to Anopheles stephensi. One is this, and the other thing is, because we need to make sure that we have a really rigorous surveillance in place. And the other thing is, as to the larviciding, larval source management. Right now, we are evaluating in Ethiopia some products, some new candidate larvicides, and of course, in near future, we will share to the malaria community the results of this evaluation. And those products are really they are performing well against stephensi. So it's difficult now to say that there is no larvicide, because I know Anopheles stephensi is highly resistant to almost all insecticide classes which has been used or which we are using for public health use. But still there are other new candidate larvicides which can work better for Anopheles stephensi, against Anopheles stephensi larvae. So it's better to again to test those larvicides in Djibouti, just to reduce the population or suppress the population of Anopheles stephensi. Thank you very much.
Thank you, Nalana Shah. How about, let me ask the Kenyan, if there's anyone in Kenya, if they also have this any association with the vector in Baden, even though this is really recent.
So Eric here. So for us, we actually did have a very quick. So let me just give context so that people understand. So our detection of stephensi was as recent as 30 days ago, 19th of December. So after that, one thing that we did with the DNMP here was looked at data, and for the past couple of months, actually maybe 2 years or so, we haven't seen any trends so far that could point towards an increase in transmission. That said, I strongly still think that the observations from Djibouti, the observations from Ethiopia, especially the ones from Djibouti, in the absence of any other vector, really do mean that stephensi is playing a role. And I think that sometimes we could be looking for evidence even where things are pretty obvious.
Thank you very much, Eric.
Nana, Dr. Ghosh here. I have one question to Dr. Delenso. So the question is that if you talk of the institutional resistance to stephensi, in adult, of course, it is all insecticides classes are getting resistance. But anti-larval compounds, especially IGRs, are you using IGRs in all these places for anti-larval measures? Like dichlorobenzene or bifoxifenes? These are very good compounds which is still working in many places. So India didn't find any resistance so far.
Yeah. Okay. Is that possible to reflect?
Yeah, because we have a session on the control and also resistance. So
yep.
we can,
okay. So I can reflect by then. Okay.
Correct.
Okay, great.
Yeah, I think Nana, we can proceed to the strategies.
Yep, we can go to strategies. All right. So as you can all imagine, with this threat, there are strategies on how to solve this problem. And you can see in the slide. Well, we know we have a PMI strategy. There's a USAID, I think, as well strategy. So yep, got the PMI strategy, we've got the Ethiopian strategy, we've got the Kenyan strategy. Maybe I'll call on Sarah if you're still there to tell us a little bit about just and there's not enough time to talk about the entire strategy, but the sheer essence of the strategy that you have, and then perhaps a little bit on the others as well, and see if there are similarities amongst them. And post masterclass, I'm sure we will create some synergies as well. Sarah, I don't know if you're there to tell us a little bit about.
Yeah, absolutely. Thank you so much for the opportunity to share. So a PMI strategy was shared last year with the 27 country teams that PMI partners with. And this action plan was really developed in close coordination with discussions with the Ethiopia team that developed an action plan with WHO, along with the WHO urban malaria framework, and really took a lot of the points from those documents into consideration. So with the PMI action plan, one of the key points, while the approach is to mitigate the impacts of Anopheles stephensi through enhanced vector and disease surveillance, coordinated intervention, implementation, and close monitoring. We outlined in this document some key activities that countries can potentially pursue based on which scenario they're in. And when this document came out last year, we outlined 3 scenarios: countries where Anopheles stephensi is present in Africa, countries that are at higher risk, and countries at lower risk. This year, we've revised the action plan and condensed those scenarios down into just 2 countries where Anopheles stephensi is present, and we're considering all the others on the continent at risk. And that was mainly due to the detection in Nigeria. So there's been some modification there. The key activities that we highlight in this document, you can see some similarities between it and the other documents, include coordination with Aedes surveillance groups, and the importance of leveraging existing infrastructure when possible for the enhanced surveillance of Anopheles stephensi. By working with Aedes groups that may already be doing larval surveys, it may be possible to detect Stevens-I in a coordinated manner. We also suggest a deeper dive look into routine surveillance data and mosquitoes that maybe do not amplify through species ID PCR. We highlight the importance of taking a second look at those specimens and no longer potentially discarding them, but taking a closer look because they may be Anopheles stevens-I, and enhancing the morphological identification. The action plan, though, however, also includes an SBC section, and in this new iteration, which should be out hopefully within the next month and online and available for individuals to use, includes an SBC guidance document as well. Some of the protocols that people have requested in the chat are included in the new revised action plan as well. But really the importance of taking a multi-sectoral approach to this challenge is highlighted. Business as usual will not necessarily work, as we've seen from other countries. So we really emphasize the importance of coordination and collaboration across borders. And PMI Ethiopia has done a really excellent job opening trainings on Anopheles stevens-I to other countries. So participants from national programs can come and learn identification, surveillance, and control methods. And one other thing I want to emphasize is that PMI revised their policy around larval source management, specifically for Anopheles stevens-I. And so with this, PMI partner countries, if Anopheles stevens-I is detected now, larval source management and larviciding can be used without the need to go through operational research or program evaluation routes, which they had to previously. So that's kind of a high-level overview of the action plan, but we're more than happy to share it with anyone, and the new version should be forthcoming. And in it, we also include the specific country maps from the Sinca et al. Paper so that PMI partner countries can take a look at maps specifically and identify locations that may be at higher risk for Anopheles stevens-I establishment.
This is excellent, Sarah. And these are also materials you can put in the MESA Resource Hub that, is like a one-stop shop to find many things malaria. It's still not up to date, but we keep putting things in there so we can speak afterwards and put these in there for other people to get access to them. All right. And then I don't know if Seth is still there. I don't seem to find you, Seth. Yeah, there are lots of people. Seth, if you're there, otherwise, Raj, perhaps you can talk about the WHO initiative it is. Please. Seth, are you there? Yes. I'm not sure if you're able to.
Okay, so we could come back to this when Seth is around.
Yeah.
But very quickly, I think one point that leads very well into what Sarah was saying, and that we could highlight also real quickly, is this document recognizes the fact that we already have 40% of the African population living in cities, and this is going to increase in the years ahead. And we will see this when you talk about the urban malaria control strategies as well. And there are three items here that are listed that are borrowed from strategies for dealing with invasive species here. And as you remember from our earlier conversations, there was some attempt to draw a distinction between invasive Anopheles stevens-I and maybe, just maybe, we have the vectors in places like Egypt as well. That's a very interesting lesson I learned today, and that we might need to dig deeper in. But then people can choose to do control, containment, and elimination. And as you've heard from Sarah here, PMI decided on a certain specific path for mitigation. But as you're saying, that they are limiting the categorization of the countries at the moment. Well, one point before we go to the next one is that we noticed during the preparation of this masterclass that actually Anopheles stevens-I is not the only invasive mosquito in Africa. And this is very interesting. I'm wondering if Bart, I know you deal with this a lot in Europe, the invasive Aedes mosquitoes. But do you think that we are ignoring invasive Aedes albopictus in Africa? I know that this is a tangential topic, but what is so special about this and not the others? I mean, Aedes albopictus, as far as I'm concerned, is pretty bad vector as well, and seems to have invaded Africa too, and nobody is talking about that. But are you with us?
Yes, I am.
Do you want to make a comment on this, please?
Well, I mean, I'm not an expert in this, but I mean, what has basically happened is that albopictus, if we're talking about Europe to start with, I think the first record from albopictus dates back to Genoa in Italy in 1990, and we just let it go. I mean, it was in Padua in the same year, and then it started spreading, and now it's as far north as the French-Belgian border. So this is a battle that we have lost. Lots of people have warned against what was going to happen. There was no concerted effort in trying to push it back. There was a lot of interest to study the bionomics, the behavior, the ecology of albopictus in Europe. There were fragmented interests in actually trying to manage the problem, either through things like SIT, the sterile insect technique, or other approaches, non-insecticidal approaches, trapping. There's lots of things that people have tried, but there was never an effort to actually try and get rid of this invasive mosquito in Europe. And if we're turning to Africa, more or less the same story applies. I mean, fortunately, there's more and more interest in the 18 mosquito species that are on the continent and looking at their role in the transmission of arboviruses, which is a good thing that it's happening now. But in the past, there was very little. In the 70s in Kenya on the coast, there was some research going on in Aedes mosquitoes, but pretty much after that, things went dry, and there's been a lot of focus on the Anopheles. So it's good that we're looking at Aedes, and God only knows where albopictus is in terms of its distribution across the African continent. So again, I'm afraid that this is where we seem to be losing a battle against albopictus in Africa as well as we did in Europe. And that actually goes back to what we're discussing here today, in that I'm really very much concerned that we're going to lose the battle against Stephen's eye as well. And the one question that I hope that we're going to be discussing a few slides from now is the key question. And that is, are we going to accept that this species is going to conquer the continent of Africa? Is that a yes or is that a no? And I think we have to agree on this, because saying yes has severe implications, and saying no also means that it will have very severe implications on what we should be doing. And I hope that we're going to be discussing that in the next few slides. Thank you.
Yeah, no, thank you. Most definitely. I just wanted to, we thought it would be nice to bring this Anopheles stephensi question up here as well, because otherwise it's completely neglected. But when you look at the literature, especially our colleagues in Sudan, they see a lot of this, and you know, in my opinion, it's as good a vector as many other Aedes mosquitoes, and I think it's therefore very, very important that we are paying due attention to that as well. Our colleagues from PAMCA, the Pan-African Mosquito Control Association, are in the audience, and I think this is squarely in their remit. So this is something that we need to be paying attention as well. And Anopheles stephensi is not the only invasive vector in Africa. We have some that are just, for some reason, completely ignored. The second thing that we wanted to raise was that, you know, if you look at literature, you see from the agriculture side, they do have strategies for invasive species as well, but you see absolutely no connection at all. In this document, for example, 2021-2030, we looked through this, there's no single mention of mosquitoes, but it focuses a lot on insects and plants. So I think there it would be really, really nice that we are integrating things as well. So let's go back to our colleagues in Ethiopia as we move towards the question that Bart was talking about. Fitsum, Delenoso, what is the plan here? Fitsum, you guys have a country level strategy as well. Can you talk a little bit about, are we eliminating stephensi in Ethiopia, or are we letting it pass? What's the plan?
Fitsum had to drop off, but
okay.
Delenoso is
Delenoso, please.
Yeah, please.
Okay, is Fitsum around? or
He's dropped off.
He had to drop for a couple of minutes. He'd get back when he's back.
Okay, okay. So the plan is actually, as you might have actually read, with the National Malaria Elimination Program, we developed actually a policy brief how to enhance surveillance and control of Anopheles stephensi in Ethiopia. And we have, the National Malaria Elimination Program, just with all stakeholders, again, developed an actionable plan for the surveillance and control of stephensi in Ethiopia that has been led by Ahari. Right now, just the plan is also to enhance surveillance and control by actually strengthening surveillance and control through capacity building and also through improving research infrastructure, and also by engaging all stakeholders and engaging also stakeholders, like putting in place multi-sectoral collaboration. So these are the main directions by National Malaria Elimination Program, really to enhance surveillance and control of these exotic invasive species. Thank you very much.
Thank you. Thank you. Thank you so much, Delena. So I think we finally arrived at the core here. What do we do? What are the interventions? What works? What doesn't work? And here really we just want to invite any of our experts who has any knowledge on this, and also our country partners. Please just jump in and let's discuss this. I think we should start with the question of bed nets here. Actually, before that, maybe if I may invite Anne Wilson, very briefly, could you just in like one or two paragraphs, if you like, describe possible usefulness of these interventions against Anopheles stephensi?
Hiya, you mean the interventions on the screen?
Yes, just an overview before we start the discussion on each of them, because I think this is really important for NNCPs.
Yeah, so I think we need to, when thinking about interventions, we need to think about the biology and behavior of the vector, don't we, and whether these different types of interventions will be appropriate, and also like the communities in which we're working. So I think those things need to be taken into account. I think my thought is, until we know the biology and behavior of the adults, I think it's probably best to focus on larval source management. We can find the larvae, we know where they are. I think for me, larval source management is an appropriate tool. And I think that's my comment. I think we need to be looking like proper integrated vector management. So combining tools, involving communities, involving other sectors. Right. It's an opportunity to have multi-sectoral control, which we always talk about, but never really gets done. And I feel like here it would be, it's necessary to do proper IVM. Anyway, that's my first thought. I'll let other people jump in.
Yeah, Sarah from PMI, Sarah and Eric, I hope you're still with us. It would be nice to hear from you on this as well. Do bed nets have a role when it comes to Anopheles stephensi?
Yeah, I'm happy to hop on and say, we still, of course, encourage the use of bed nets. I think that's important to emphasize. That's still a top priority, of course, and we want to make sure that message doesn't get lost. But I think, the evidence that does exist so far on resistance to many of the insecticides that are used in the ITN should be taken into consideration. And I think to date, we don't yet have much data to support that they will not work or that they will work for Anopheles stephensi. So as Anne mentioned, the importance of understanding binomics is critical to understand the potential use of that intervention.
Right. And I assume your answer applies to all the different types of bed nets that we have. Amuda, please. Dr. Amuda, you're muted.
Okay, thank you very much. Actually, maybe before I'm talking about the control, maybe as I mentioned, still we are not complete the work on the bionomics of the vector in the country, but now I can say that the country already here in Sudan, for example, we have the stratification of the intervention. For example, the irrigated area, we're doing here in Sudan indoor residual spray. And now we just completed the distribution of 18.3 million long-lasting nets. This is the normal interventions that we're doing. But a part of the project, what we need to do in the last year of the project 2014, we will have like small trials assessing different intervention to see what's the suitable intervention for controlling Anopheles stephensi. But still now I can say that now because we now widely distribute long-lasting nets covering more than 35 million Sudanese people in mainly concentrating in rural areas, maybe we will still see what's the impact of this on the Anopheles stephensi during our work whenever in case control study or in the bionomics study, or even for entomological routine entomological surveillance, where maybe we will see something different. But now the country is starting registering new product natural DT from Clark. Maybe this kind of intervention maybe will support what we're doing in the urban setting. For example, in Sudan, there are 110 urban setting mainly allocated for larval source for LSM. Maybe this will be will add much on this work, and after that we will assess that and we see what's going. But now we still not have like a specific intervention to be targeting Anopheles stephensi alone. This according to stratification. Rural areas with long-lasting nets. Now 18 million is just distributed, supported by Global Fund, and larval source management in 110 urban setting areas. And during the main transmission season, also another intervention could be added. Maybe this is what going now, and then we will assess what exactly suitable for control. Over. Thanks.
Thank you very much. Delano, show your hand's been up for a while.
Yeah.
And Dapo, is that Dapo a friend from Nigeria, right? NMCP?
Yes,
okay.
It is.
Delano, so go ahead, and then after you.
Okay, thank you very much. Just I want to just say something on surveillance and control. Really, before control, actually, I want to say something on surveillance. Right now, in most of this historically, I mean, in countries where historically Anopheles stephensi was there, and also in newly colonized territories or countries, we are seeing that even we don't have good surveillance tools. We could collect as many larvae as possible, but we are unable to actually collect adult Anopheles stephensi. This is obvious. And in order to characterize or to study the bionomics of this species, really we have to have just an improved tool, surveillance tool, where we can just collect as many adult Anopheles stephensi as possible. So we don't have to only focus on the control intervention tools. We need also look into how we can just get an improved tool, how we can develop an improved tool or improve a tool that can be helpful to collect adult mosquitoes. That's very, very important. As to the control, I think, yes, we need to have a data on the biology, ecology, and behavior of the species, because right now we have been discussing just about long-lasting insecticidal nets, whether it is pyrethroid or PBO-net. But really, does that will help us much? The problem is this species is outdoor resting more of, and outdoor just feeding. In that, with that this will help us, but we can just put it as just to complement some other control intervention tools. But that really, will these conventional tools be helpful to control these invasive species with really with the high behavior plasticity of this species? That is the kind of thing that I want to say, because we need also to focus on developing an improved surveillance tool for this species. Thank you very much.
Thank you, Dalanusa. Adedapo?
Yes, thank you very much. What I want to say is that it just looked like Delina Shaw read my mind completely, as if we were in the same place together, and he read my mind. If we look at the data we are getting in Nigeria, Nigeria happens to be the place where the first place where we got them in West Africa. And if we look at the kind of data we are getting and what we are seeing, the trend we are seeing, it is quite evident that there are so many blind spots with this. One. Two, it is quite evident that the current tools we're using have to be modified for us to be able to get this species. I could say that a lot of people are having issues with the current, if you want to get adults, you use current maybe CDC light trap, human baited CDC light trap. I tell you, you may not get Anopheles stephensi using this. You have to make some modifications to it to be able to get Anopheles stephensi. So I think definitely before we start, like Helena should just say, before we start thinking about the intervention, we want our interventions to be evidence-based. What is the evidence that we have now for we're talking about Teleline? Yes, Teleline works, it works perfectly. But even our data from Nigeria shows clearly that these species don't feed. We did some research here and we did not see a single Anopheles stephensi indoor. So immediately we started setting our traps outdoor, we started getting Anopheles stephensi. So at the end of the day, I think we need to do a deep dive, a reflection of some of the current vector control activities that we are doing, to look at them critically and see the form of modification we can make so that our intervention for this particular species will be specific and it will be evidence-based, so that at the end of the day, we'll be able to target this and probably deal with it, with the challenges of this species.
Excellent. So Dapo, both yourself and Delena, so what you guys are suggesting is that we still have a long way to understand the biology of the adult mosquito. I know we have our colleagues from India who have been dealing with this for many years. It would be really, really nice to hear how they have dealt with it in Africa. But before that, I also know that our colleagues in Kenya have recommended in their publications of spoken about possible alternative technologies that could be used. So we should discuss all those very briefly, and then we proceed to the next stage. But before that, Dapo, shall we just assume then that indoor residual spraying is probably not the best, it's not good enough for Anopheles stephensi in Nigeria?
Now, I will say that before we can conclude, what we are saying really is that we need more data. We need more evidence. Because at the end of the day, looking at this species, there are some factors. It's like talking about a biting cycle. You first of all have to look at the species, the exact species that is involved, and then you overlay that with human behavior. Now, human behavior might differ from one region to another, but when you overlay it, it becomes interesting. It gives you an idea of the reason why some mosquitoes will come indoor and why some will come outdoor to feed. So I think we need a lot more data, a lot more. And once we get, and this data has to be seriously localized from one region to another, because there might be variances. The behavior of Anopheles stephensi in certain areas might be different from what we are getting from another. And so at the end of the day, by the time we appreciate this and put this together and we have enough information, we can make decisions, good decisions and targeted decisions at this species. Over to you.
Thank you. Thank you very much. For the sake of time, I think we're going to move forward. It seems, Nana, that the main intervention, therefore, is the formerly neglected larval source management. So Silas Majambere, my colleague in the call here, you guys have been calling for expansion of larval source management for many years. Now, this seems to be the only, the primary tool that we have on hand. Silas, are you still with us on the line?
Yes, sir, I'm here.
So thou shall not cry anymore. So now you have, do you think WHO should make a recommendation or we wait as well?
If I have to be honest, I've given up on waiting for a recommendation. I think if we know from other places what they do for container breeding mosquitoes, or even a mosquito like this that has some plasticity, while we're waiting to find that amazing magic bullet that we always seek for, I think we should just use what has been used elsewhere, larval source management, outdoor spraying. No one is talking about that. But all those interventions have been used elsewhere and they're working. I don't see why they wouldn't work in Africa.
Thank you. Thank you so much. So I think we can skip this, but some of the suggestions that have been made are that you could also start to look at, especially because Anopheles stephensi is cow loving or blood feeds on animals, that you could use things like endectocides. I think someone posted a question here for Eric Ochomo on that. It's nice if you can comment on that. ATSBs, spatial repellents, traps. So again, if anybody wants to put comments on the chat regarding the possible effectiveness of this against Anopheles stephensi, that would be great. The other development that we know is the use of genetic modification against Anopheles stephensi, and there is a great work pioneered by our colleagues at Oxitec, and I believe that at least one of them is on the call. Nathan, are you on the call?
Hi, Fredros. I think Nathan is still not on the call, so I'm happy to step in if that's helpful.
Excellent. So if you guys don't mind, if you could just describe very briefly the work that Oxitec is doing in Djibouti, and how you think this might be translatable as a solution against Anopheles stephensi in Africa.
So perhaps we're best known for our work with Aedes aegypti, which was one of the species we talked about earlier. And most of that work has been done in Brazil, also in Panama and other parts of the world, and currently piloting in the US, in Florida. The highlights of the technology are its Vitex solution, as you mentioned, Fredros, genetically modified males designed to confer repressible female mortality. What this allows us to do is to produce large numbers of eggs of our Aedes aegypti mosquito, our friendly Aedes, as we call it. We can distribute them around the world, taking advantage of the egg dormancy of Aedes aegypti. And we can package them up in egg release devices, a bit like the box you see on the left there. Place them in the field, add water, a bit of food. And over the next few days, friendly males come out that females can't survive. And so, for us, it's a kind of sibling technology to the sterile insect technique, if you like. It works by a similar method. Our males go and find females in the environment, and at least some of their offspring are non-viable. And we've demonstrated its efficacy in multiple pilots, many in Brazil, and you can see an example in that graph in the schematic there. So typically over 90% suppression, often in densely populated urban areas. And so, it's another tool for the toolbox for vector control, self-limiting in the environment. I should get that in there. It's different to gene drive. So in some respects, perhaps easier for regulators to look at. So, on that basis, we are fully commercialized in Brazil, and now selling a product to cities, businesses, and even households in Brazil. Okay, so moving across to the mosquito we're talking about today, Anopheles stephensi. So with the support of the Gates Foundation, for the past few years, we've been developing a solution, a friendly Anopheles stephensi, for application in, for example, African settings where we've seen such high spikes of malaria, essentially in Djibouti so far, but also now in Ethiopia. So while we finished development of a self-limiting Anopheles stephensi, in our UK labs, we've now partnered with NGOs and governments and government entities in Djibouti, national malaria program there. And for the past 12 to 15 months, we've been conducting surveillance of Anopheles stephensi in communities in and around Djibouti city. I guess a highlight there is that in all of those communities, we found Anopheles stephensi. The vector was present year-round, dipping in the hotter seasons, but able to survive right across. So not solely an urban vector. And, by that, that would tell us that, obviously it's pretty widespread across Djibouti. And I guess many colleagues on this call would say it's pretty widespread across the Horn of Africa and other parts of Africa by now. So to kind of launch the next phase of the program, we held a stakeholder workshop in Djibouti last week, inviting members of the community, government officials, WHO, local NGOs, and also international partners to share more about the project. And over the next year or so, it starts to become real, and we'll start to think about deploying our friendly.
Neil, is the intention here to go after stephensi for elimination?
We're looking at that. I mean, with Aedes aegypti, we're able to drive populations right down, local populations in treated areas. And if we were to keep pushing on that, I suspect, local populations could be driven to, elimination, if you like. And so that is a feasible outcome in some settings. But I think, using our technology for kind of region-wide elimination probably isn't the option. But, perhaps the primary use case is to ensure that we deliver, highly scalable, highly effective, targeted vector control in communities that are particularly at high threat of urban malaria, and then take it from there, and perhaps local elimination or prevention of invasion could be possible use cases.
Thank you, Neil.
Yeah, Neil, I have got a question. You are having stephensi, what oxidative methods. Then, unlike Aedes mosquitoes, you can grow in numerously. How we are going to grow stephensi?
Well, that's what we're working on in parallel. So we've developed a highly scalable manufacturing platform for Aedes aegypti, and for the past 5 years, we've been kind of transferring some of that knowledge into developing a similar system for stephensi. Of course, the downside with Anopheles is you can't hold the eggs for months at a time, and so obviously, I think local production is probably going to be, our chosen option. We can't distribute Anopheles eggs from the US or the UK, I suspect, in this circumstance. So there will be differences, but certainly the high-level principles we feel will add value to the mix of tools available to vector control workers in Africa.
We have developed a modified technique which we can produce numerous numbers of stephensi, because I was handling one P5X liver stage assays, and then the challenge was how to grow stephensi with infected 5X mosquitoes, and we would overcome this modified method. I can help you if you need my help.
Reach out. You can find my and other contact details on our website. I'm here. My door is open.
Okay. Because you need to have a large number of productions of stephensi.
Indeed.
Yes.
Yeah.
Yes, and we used to produce almost 20 to 30,000 per week in our lab. Only I'm talking of adult females only, except males. If you add males, then it will be another, say, about 60, 70,000 per week.
Thank you.
Limited options. Yes.
Yeah, we're producing many million Aedes aegypti.
Egypta is very easy. Egypta is very easy. But I'm talking of stephensi, it's a tricky one.
Cool.
Yeah.
Cool.
Yes.
Cool. So I think this is also like a fairly early stage, but it would be important. I think it leads us to our next chapter of this conversation, given that we are actively seeking, and most countries are actively seeking opportunities to possibly, contain or even eliminate the species locally. I'm just wondering if my colleague Nana is on the call. Nana, yes, please.
Yep. Okay. Yep. Okay. So here, I don't know if Bart knows. Are you still there?
Yes, I'm here.
Yes. Okay. Just wanted to ask you, what do you think about the eradication of Anopheles stephensi in like with example in Brazil?
Well, I think many on the call will know this example. For those that don't, very briefly, we're talking here about an invasion of Gambi. Well, later on, it might have been Arabiensis in the northeast of Brazil back in 1930. And just like we've seen with Albopictus, as we discussed, and as happened with stephensi in the Horn of Africa, we detected it, but we let it go. And that happened also in the northeast of Brazil. So it invaded in Natal, all in the eastern part here. And then it spread over an area of 54,000 square kilometers in a period of 8 years. And then in 1938, there was a dramatic outbreak of malaria. There was a big epidemic. Some 200,000 people went down with malaria, some 15,000 deaths. And that's the time when the man that you see here in the picture, called Fred Soper, he stepped in and he tried to get funding from the Rockefeller Foundation to not only control this problem, but actually wipe out Anopheles gambi entirely from the northeast of Brazil. And at that moment in time, and I think this is very important, at that moment in time, there was no indication that this could actually be done. And so he went to the Rockefeller Foundation and he managed, against all odds, to get a blank check to do the job. And he went back and basically he argued that if they would not get rid of Gambi in Brazil, that the epidemics that might ensue as a result of that would pretty much become similar to what is seen that Gambi is doing in most of Africa. So there was a strong call to eliminate. And I think this is coming back to the question I asked earlier. Are we going to contain? Are we going to control? Or are we actually going to eliminate? And I think we need to answer that question because it will determine what we can and what we cannot do and what we should and what we should not do. In this particular case, the answer was very, very clear. We're going for 0. And the end result can only be 0. That's success. So anything that we add to the toolbox, we just talked about the Oxitec mosquitoes, anything we add to the toolbox, Oxitec has, as far as I know, never been able to eliminate a population locally. It's always been 94, 96, 98%. It's a great tool, but it's not a tool that is going to help us to go down to 0 and get rid of this problem entirely. So at the end of the day, what we need to go for is strategies whereby we say we are giving the best shot at going for 0. And what does that take? A lot of what has been discussed in this call today is what we know about this species, how we can detect it, how we know where it is, which is prime. It's essential. Know where your enemy is before you can get rid of it. But in terms of the bionomics, which we have discussed, and the gaps in our knowledge in terms of the ecology and the behavior of the mosquito, of Stephen's eye, in the case of Gambi in Brazil, there was very little knowledge about the bionomics of Gambi in that particular setting in the northeast of Brazil. We didn't really know what it was doing. But Soper and his crew of more than 4,000 people did not bother about that. They just went for water, standing water where they knew that Gambi was breeding, and treated with a larvicide. Admittedly, at that time, we didn't have anything that could be used for IRS. We had pyrethrum, but it would only last for a few days. So there was no DDT, so there was no really any concern about indoor, outdoor biting, these kind of things. Bed nets were not there. So the focus was exclusively on larva source management. And larva source management has been discussed in this call. I'm very happy about that, to be honest, that we are seeing this because larva source management is going to be a prime strategy for targeting the Stephen's eye problem in the Horn of Africa. But if we then say LSM is going to be the tool of choice because we have to cover a lot of terrain, then the next thing that we need to discuss is who is going to fight the war? Who is actually going to be out there? There's 300 people on the call now, here in this Zoom call. There's probably a few hundred more on the YouTube, but watching it live there. And I would ask, does Eric, in his particular outbreak in Marsabit in Kenya, does he have 300 people there who are now out there actually wiping out this small outbreak or determining the extent of this outbreak in Marsabit and surrounding areas? The same applies to Nigeria. It was detected there. Now, who is actually on the ground fighting the war to get rid of that outbreak of Stephen's eye in Nigeria before we let it expand further? Because the longer we wait, the longer we give it an opportunity to spread, and the more difficult it is to going to get rid of it. And it's going to be another example like we discussed with albopictus in Europe. So these are, in my view, critical questions that we need to address. And I think a lot of people on this call all chip in parts of that puzzle, all have specific answers to details of that big overall question. But I think at the end of the day, what it will come down to is whether we can get a coalition of people together to drive an effort forward to obtain very significant amounts of funding to actually get rid of this problem altogether, because that's what it's going to take. Either we're saying we're going to spend a lot of money on it now and actually go down to 0 and get rid of that entire outbreak of Stephen's eye in the Horn of Africa and Nigeria, or are we going to let it go and we can study it to the death and we can look for new insecticides and we can look for new this and new that. But at the end of the day, it's been predicted that we're going to get millions of extra cases every single year. And that, of course, is going to be an extra burden and it's going to be an extra cost again. So these are the critical questions that we need to address. And I think that's why I'm very keen and happy that I was asked to be on this call, because that's exactly what we're trying to do in Asia at the moment. So in Asia at the moment, if you go forward, yeah, this is the slide. So what we're doing in Asia is we're trying to target the Aedes and Culex mosquitoes, because Anopheles is not an issue in the Maldives, where we've been working for the past 3.5 years with my colleague Akib Jahir from India, who's on the call, I believe. Anyway, so what we're trying to do on these islands is to learn how to eliminate mosquito populations. And I'm happy to report that on some of these islands, using traps developed by Biogens in Germany, that we have come up with a formula to use high density trapping as a means to actually eliminate, excuse me, to eliminate these populations. And I think that's the same thing that we need to do here. We need to learn what it takes to eliminate populations of Stephen's eye. And I think these local outbreaks that we have, the one that we just heard from Eric in Kenya, they lend themselves ideally because they're more or less an isolated outbreak, an isolated population. And those would be ideal to target with a toolbox to see what it takes to actually get rid of that outbreak altogether, and use that as a template then to go to scale sorry, in these other countries where they're battling with the same problem. That's my 2 points. Thank you, Brett.
Thank you, Bart. Nana, you're muted.
Yeah, thank you, Bart. I was going to say thank you very much for that. Frederick, over to you. Should we move?
Yeah, no, I was just going to ask Bart, what would you do if you were Eric? And Eric, it would be nice to hear your response on this as well.
Eric, you want to go first? Is Eric
I am waiting for you, bud.
Okay. Well, I think your first of all, congratulations with your work. I think it's fantastic that you've been able to trace it. I think it's really important. So now that you found it, the question is going to be, what are you going to do about it? I mean, there was talk about surveillance and maybe trying to find adults and some other things that you can study. Studying is one thing that is needed. The second thing that is needed is, how do you fight the battle to get rid of that outbreak? How do you get down to zero Stephen's eye in Mazabit? This is a question that we can ask ourselves also with respect to Gambi and Phonestis and Arabiensis, the other major vectors that we have in sub-Saharan Africa. But in this particular case, it's particularly prudent to discuss the issue, what do we throw at it in order to go down to zero? And I'm afraid that at this moment in time, there's if anyone is there in the call that has an answer to this, I would love to hear it. And I think the reason why we don't have these answers straight up front is that we have not learned in the past few decades what it takes to actually eliminate vectors from particular areas. And I think that's what we're trying to do with my team, is that we're trying to learn how to eliminate mosquito populations from areas that they have invaded. Over to you, Eric.
Great, thank you, Bart. And so for us, one thing we've thought about doing instantly is intensifying the surveillance that we're doing. And actually, community-based approaches are next on our list. So what we intend to do is train people in the community and equip them. Equip them here, meaning that we get them level sampling equipment, get them adult sampling equipment, and have them go out and sample. The other thing that we're thinking about doing instantly is Latin square studies of different trapping methods, just to try and see if we can detect the adults. As that is happening, luckily for us, the DNMP here has already been implementing larviciding in Western Kenya, and this has been in response to Gambi and Arabiensis, Gambi, Arabiensis, and Phonestis. And so we right now lobbying for the movement of larviciding to these same settings. And so we hope that will happen in the course of the year. We're having those meetings with DNMP now. And we hope that with this, we may be able to see some traction in being able to actually deal with Stephen's eye.
So if I may ask, how many people do you have to actually do the control work or the elimination work on the ground in Mazabit at the moment?
I wouldn't be able to actually speak to that, because that has to be the role of the National Malaria Control Program, which I'm not part of. But I will definitely reach out to them and figure out what we can get. The one thing that though is that there are lots of locally trained entomologists all over the country, and as I should.
Oops.
Well, I think we're losing.
We lost him.
From them up, there's been lots of surveillance going on, and it'll be pretty straightforward.
Yeah, but I'm wondering whether we can hear from our other experts, just any of the experts in the team, please just jump in and make a comment on this specific issue. Can we and should we eliminate Anopheles stephensi from Africa?
Pedros, if I say, my question is that, stephensi is a mosquito which has, every species has got a bunker. If you don't strike the bunker, I think we cannot eliminate this species. What we have done in India, we are using combination of fish. Larvivorous fish is very, very effective. And there, this type, mostly this stephensi breed in wells. All the coastal belts in India, they breed in wells. Nobody knew that they're breeding in wells. And we struck with guppies. You don't believe it. Now we have done digital surveillance, actual digital surveillance mechanism there, and malaria has crashed down over the 5-6 years. And as a result, the entire state in Karnataka and India, it has gone down less than 300 malaria cases, and we are on the phase of elimination right now. So that it is published in Malaria Journal, 2 articles back-to-back, 2019 and 2021. And if you follow that case-based surveillance, we have done the case-based surveillance 1, 2, 3, 1, 3, 7 plus 14, because we are also Vivax here. So we are following up the patient. There is a vector control team. Immediately they go and then case around, they search them and they do all vector control activities, and the result is very, very fantastic. So before I went into that town, nobody knew that stephensi is breeding in the wells. They didn't believe it. But I took some time to convince them that stephensi is breeding in the wells. They were concentrating on some other breeding sources. But when you do very targeted interventions, and especially in the construction sites, so Dr. Raj talked about the construction sites, especially in type forms, stephensi. So you have to be very, very, careful, like Mumbai, like many cities, is zoomed on building constructions. Aedes mosquitoes, especially Aedes aegypti and stephensi, these 2 mosquitoes, they co-breed. And Dr. Bart, I have read your paper, very wonderful, but the people, it is at all holiday islands, and people are asking whether it is possible for stephensi, where is a bordering, zones and all. What I find from all the discussions, and then also I met many people during my meetings in, Seattle, STMH. There are a lot of discussions on stephensi, and Sarah and all of us there. I find there are variant distribution you might find. If it is type form, it is very easy. Even in Mangalore, we did the IRS. No IRS is recommended by our National Control Program for urban area. There is a special urban malaria scheme in India targeting stephensi only. No IRS, only larval source management is the prescribed forms.
Thank you so much.
Yes.
Thank you so much.
It works.
So I think we should. No, this is a Tessa. Are you still on the call, Dr. Knox?
Yes, I'm here.
What's the point? Go ahead, please.
Sorry, the point that I made in the chat, is that what you're referring to?
Yes.
Yeah, I think it's just really important that we continue to maintain focus on what we're collectively trying to achieve here, which is essentially using all the data that we're collating, collecting, discussing, collaborating on to make sure that we're giving clear recommendations to NMCPs, because essentially they're going to be the ones that need to be changing what they're doing, maybe updating their malaria strategic plans, their operational plans as well. So it's essential that we're clear with where we're going with this, and that we're collectively speaking sort of the same language, and also considering things beyond just stephensi and the massive interest that there is in it now, but considering what impact could this have on coverage of core interventions that we know work, because there's a limited funding envelope for malaria. And if we're now looking at increasing funding to surveillance, what impact is that going to have on the ability of programs to be able to deliver interventions? So I think it's just maybe just a comment to maintain a bit of perspective and make sure that we are ultimately focusing on human health and the impact of all of the work that we're doing and how that can feed into the decision-making for NMCPs ultimately. Thanks.
Right. No, thank you. Thank you so much. Thank you so much for that. I think we've discussed a lot about the interventions. Sometimes we forget also the human behaviors and activities and perspective side of it. And whatever we do, we have to communicate it very effectively to our stakeholders. And therefore, I would like to invite at this stage, if possible, our colleagues from the Johns Hopkins communication programs to just describe to us a little bit briefly how you would structure specific, you call it SBC, social behavioral change communication. How would you structure this with respect to two things? Number one, places that have Anopheles stephensi already and places that do not have Anopheles stephensi but could possibly have Anopheles stephensi in the near future. What kind of messaging, how do we do this? How do we craft these messages so that we are getting the most out of our stakeholders and also encouraging participation of the community members? April, are you there?
Hi everyone. Yeah, thanks. And I'll build a little bit on maybe what Sarah Zodi shared in terms of the SBC strategy that's been developed as well. But I'm glad you raised this point, just to say it's really important to think about the role of individuals, households, and communities. And especially with some of the interventions that we're talking about, I think there's a really big role for people to play in supporting the response. And so it's important for countries to be thinking about social and behavior change strategies as they're developing their response, as they're choosing these interventions. And so to your questions, I think across the board, it's important to act early. So to raise awareness about the threats, to let people know what they can do to protect themselves. So keeping communities informed about emerging and potential threats. And that's really important from what we've seen in terms of building and maintaining trust in the response. And it's important to keep in mind as well that perceptions of risk may be lower in some of these areas where maybe transmission has historically been lower. So we want to think about letting people know why it's important to do some of these interventions. Sorry, we have a little guy in the background. To let them know about some of these unique features that some of our colleagues have raised about the fact that stephensi can be an issue in urban and peri-urban areas, that it's can transmit in the dry season as well. And really to let people know why we're doing some of these new interventions. And then, what programs should keep in mind. Again, I think we can learn a lot from our 80s colleagues on this and some of the techniques that they've used to promote some of these larval source management strategies. And one of the most important things is just to be as specific as possible to make sure that we're giving people clear and specific steps that they can take. What we've seen with some LSM strategies, so things like removing standing water or covering water storage containers, is that general messages can not only be ineffective, but in some cases can be harmful if water storage containers aren't being covered correctly. They can actually create additional breeding sites. So making sure that we are as clear and specific as possible, and where possible really are working in tandem with our messaging, with our SBC strategy, with 80s programs where they exist, and in some cases as well with WASH programs. Thanks.
Can you comment a little bit also on how you do this for interventions?
Can you say that again, Pedros?
Hello?
Yeah. So in terms of the different interventions, so I think we think about it in kind of two different ways, right? So there are some of those core interventions that our colleagues have already been talking about. And it sounds like we don't yet have a good answer about when and where some of the core interventions continue to be effective against Anopheles stephensi. But what we do know is that a lot of times Anopheles stephensi will be co-located with other anopheline forms and other anopheline species. And so it is important to let people know the importance of continuing to use those strategies, to not stop just because new interventions are being implemented. And then when we're thinking about some of these interventions that maybe have traditionally been used for Aedes control, but might be much less familiar to people, so some of these larval source management interventions, it's important to let people know why we're doing those. And again, how to do those effectively, what their role is in the process, and making sure that they're being done correctly. And one that you don't have up here that we also think is important is early care seeking for fever. So that's something that is already being promoted, but in areas where transmission maybe has been again, historically lower, really letting people know that there is a threat, that it is important to seek that care. And that's important not only for their health and for making sure they're getting prompt treatment, but also for identifying spikes in cases early and to make sure that people are going and getting tested, especially in places where maybe a fever isn't always malaria. So those are some of the things that we're thinking about with these different types of interventions.
Thank you so much for that. For this, hopefully this is something that is continuing to develop as we learn more about Anopheles stephensi, and that we can have a greater understanding on how to structure this communication. So thanks a lot to our colleagues at CCP and also our colleagues at USAID for working on these aspects. Because of time, we're going to speed up through some of these slides, and then towards the end, we'll re-engage and draw towards a close. So I think one theme that has featured a lot during this conversation has been the question of Anopheles stephensi and Aedes, different forms of Aedes co-occurring together. You see here a very good illustration of how the current interventions are focusing on, number one, rural areas, and number two, focusing on the salmon vector species. Sorry again. Just one moment.
Let me take it from Frederick. Yes.
Yes, Nana, if you can
Yes.
check this off, just handle
Yeah,
Frederick
let me
to
take it from Frederick, yeah. So we've seen that. Oops, this microphone. Delena, sure. Wait, can you take your intervention, because and after we can silence.
Okay. Thank you. Just to put one final remark, just a 1 minute or less than a minute remark. So I want to just tell to those esteemed experts to be cautious on one thing. That is, detection of Anopheles stephensi in one area doesn't mean that it occurs everywhere in that country or in that territory. We need to be careful that if we want to study the biology of this stephensi, by just establishing or putting in place an insectary, we should set up that insectary in an area or in a setting where it has been detected or occurred. Don't move just or bring stephensi and put an insectary in an area where it's not detected, because it will be self-spread or self-distribution. So we need to be careful. It is always good to try to control or contain these invasive species where it has been detected. We don't have to actually spread by ourselves. That is what I want to say. Thank you very much.
Thank you, Dalanasha. All right, let me quickly move in there. Let me move to urban malaria, Frederick.
Just if you don't mind, just real quick, and then we go to urban malaria. Is that okay?
Yeah.
Yeah, I think the point that Delena have made is really critical. There are a lot of scientists on this call, and I think this is something that most people might take for granted just because we are excited to study Anopheles stephensi. But it's really, really important that you're paying attention whenever you want to set up an insectary of this. Maybe just think very carefully with your local biosafety authorities and IRBs before establishing this. Otherwise, it's going to be chaotic. This thing spreads like wildfire. It's very, very easy to establish it, and it can easily take over without knowledge. So Abraham already spoke about this, and it's important that we are also paying attention to the global vector response. There are a lot of people on these calls who have worked on the global vector response initiative that ties in very, very well to the subject that we're discussing here. Very briefly before Nana takes on the urban malaria control, urban malaria strategies, I just want to highlight a few issues here on surveillance very quickly so that we can close that chapter. It appears to us at the moment that whenever you look for Anopheles stephensi, you will find it. So it's really difficult to know where it has spread, how far it is. So maybe we just need to continue that. But our colleagues from Ethiopia and South Irish and Sudan published a really nice paper here recently where they described what we could do, what new people in countries that have not yet identified Anopheles stephensi, what they can do in that. And they describe here 4 types of surveys. They describe an exploratory survey, post-detection surveys, then rapid surveys in small areas. And then after that, you can begin studying this ecology and the bionomics of Anopheles stephensi. So again, just for our audience, you might want to pay attention to that specific paper. It gives for a fairly good introduction to people who want to start doing surveillance on Anopheles stephensi. I know that colleagues in Tanzania, for example, Uganda, Mozambique, are on high alert, thinking about whether this vector has arrived there or if it will arrive, and you might want to set up some surveillance platforms. So we just wanted to share that. The other thing we want to share is that identification for Anopheles stephensi is not necessarily, can you guys mute please? Identification for Anopheles stephensi is not necessarily a straightforward thing at the moment. People are relying mostly on larvae, and then you definitely grow this to adults, and you're looking at the pulps primarily. Or if you look at the keys, we have now an update from Maureen Cossey's keys that now includes also Anopheles stephensi. For a long time, we didn't have this updates, but thankfully from 2020, now you have those keys. Our colleagues from IRD, Dr. Neil Rihole here shared these slides with us to bring to the masterclass, and I'm very, very grateful for our IRD colleagues. Would you please mute whoever is on the call? Our co-hosts, can you help mute everybody else? Yes. So again, a great shout out to our colleagues from IRD for preparing this. But this is one method that you could use to detect Anopheles stephensi. I think the most important here is that you have this light here. If you look at the third dark area on the wing there for Anopheles stephensi, it's very different. You see the white spot there for Anopheles gambi that you do not see on Anopheles stephensi. Instead, you see the 3 bands there. And you also see the differences in the pulps. That is probably clearer on the images here from Eric Uchomo's group. So those are some of the important things that you want to look at. You can refer to these slides later, or just look at the key.
Nobody has up again.
Elkanah, Professor Elkanah, kindly mute. I'm trying to mute you, but I'm unable to, so I'll probably just remove from the call. Good. Hopefully you can rejoin. Just so you know, my colleagues at Ifakara Health Institute have taken the Professor Maureen Cossey's keys on Anopheles stephensi, on Anopheles, Afrotropical Anopheles, and they have made a mobile application for that. So this is now available on the Google Store. I believe it's okay. If Nixon is on the call here, that people can download this and try it out. Again, we are grateful for the support of PAMCA, support of Dr. Seth Irish, and support of Professor Maureen Coetzee, herself, and Lisette Kaikomar, who have supported the development of these mobile application keys. So this is now available, and just so that you guys are aware of it, you may want to download that and try in your own fields. Of course, it includes stephensi, but it's really just a replica of that, and it's called Coetzee. I think that's the name of the mobile application that you can find. In terms of data collection, we still don't know much, and I think it has been highlighted here that a lot needs to be done in terms of that. Lastly, molecular detection. At the moment, there are no specific PCR protocols for detecting Anopheles stephensi. Instead, you sequence ITS2 or TO1, and then you detect it this way. And this is what all the groups that have currently reported Anopheles stephensi have done. For Anopheles sporozoite, the only major thing to say here is that standard ELISAs work, but because of the high likelihood of zoonotic protozoans, it's best to boil the lysate, lysate, because then this takes away, what shall we say, takes away potentially zoonotic plasmodium that happen to be heat labile. Plasmodium falciparum is fairly heat stable. So those are the comments I wanted to make, and then after that we will jump onto the relationship between this and urban malaria and draw towards a close. I see that Eric has a hand up, and then we can go back to Nana. Eric, please.
Just to mention that there's actually a conventional PCR technique, which is what we use for the stephensi detection.
Oh,
I'll share the
Can you put a link on the?
Yes, I'll do that.
On that. Excellent. So, and Nana, it looks like I forgot the resistance question here. So we have the insecticide resistance. That's another challenge. Unfortunately, from these reviews, as you can see, a lot of resistance on Anopheles stephensi. Very interesting compared to other species, in the sense that here you have a vector that is resistant to all classes, everything, including organophosphates. That's fairly interesting. This study from Ethiopia illustrates this very, very nicely. Of course, also reporting the absence of KDR there. So you can see resistance across carbamates, organophosphates, organochlorides and pyrethroids, everything. So stephensi really is a difficult one. So Nana, please take it up, and if we have time, we'll come back to the models. You're muted.
Sorry, I'm muted. Yeah, I'll be quick. We all know that the world population is on an increase, particularly in the urban areas as well. And it is estimated that in the urban cities in Africa, the population is going to increase as well. So here we're talking about lots of numbers that will be exposed to the burden of malaria. And what we've learned in the beginning during the sector for and the biology of Anopheles stephensi, we learned that it's really fit, and it's capable of being in containers, in tanks, and all other places. So this is very important for us to find the overlap in all the interventions, and also with the focus on the fact that the cities and the population in there are also on the increase. The WHO did a technical consultation and came up with a global framework for the response to malaria in urban areas. And in there we had the lots of activities and discussions that came up with how to integrate efforts, considering not only thinking of rural, as has typically been done, rural in malaria, but then also the concerns in urban areas. Fredros, back to you.
Yeah, so for me, it's a question really. Let me just see if I can get back to this. And the question here is, we'll skip that. Yes, so we spoke to one, can you hear me, Nana?
Yeah.
Yes, we spoke to one expert who said to us that, they are very happy that WHO has released this new framework on urban malaria control, and that this is going to be super useful for Aedes, for Anopheles stephensi. But then he also told us that, we have to remember that this is not going to be based on commodities, that it might not necessarily be driven by entomologists, and we have to be open to that. and that we have to realize that the responses to Anopheles stephensi would need to be integrated in the responses to other things, including the need for clean water. That we have to watch out for trade and mobility, and borrow a lot from what the Asian countries have done. So here then is my question to our experts here. I don't know if Dr. Raj is still with us, and if Seth was able to get back here. But I hope you're still with us, and Eric as well. Could you guys, would like to hear, what are your comments on this narrative here? Do you agree? And if you don't, what points don't you agree with? What can we emphasize here? How can we use the framework on global response for malaria in urban areas to support the work against Anopheles stephensi? Back to you guys.
Ferdous, yes, I am still there, but could you repeat the question, because I didn't fully understand.
Yeah, so these points have been raised by an expert who worked on the global framework for malaria response in urban areas. And our question to you guys is, do you agree with this perspective? Are there points here that need to be emphasized? Are there points here that you don't agree with? And it would be nice to hear from different stakeholders on this subject.
So actually,
so just very quickly from each of the experts as we draw towards the end.
Yeah. So please don't mind. Actually, I would like to defer this question to global malaria colleagues, because they are responsible to give a policy statement rather than me, which is because this is not my direct responsibility. And also some of these questions may be thought over correctly, because this would imply a policy statement from WHO. So possibly we can answer these questions offline, and then you can share among all other people.
Okay,
yeah,
that would be good. Yeah. Any other experts want to comment on this?
Yeah, this is Eric. So yes. The one thing that we have to sort of agree with is that this is a totally different vector from what we're used to, and therefore we will have to think outside the box. We will have to think about multilateral collaboration. So yes, definitely there will need to be a lot of thinking around engagement of more than just the partners that we're used to working with. I totally agree.
Excellent. Excellent.
If I may make a comment,
yeah,
I think one important issue, and it again comes back to the question: are we going to try and eliminate this invasion, or are we going to live with it? If we're going to live with it, then doing everything you can to engage communities in helping you to curb this problem, to keep it under control, is going to be totally fine. If your aim is going to be that you want to eliminate this entire invasion in the Horn of Africa plus Nigeria, then over-dependency on what your community is going to contribute to your elimination effort is, I think, a very dangerous thing to do. What you would want to have at any time is community consent, and that's going to be particularly important in densely populated urban areas. You need community consent before you can move forward. But to depend on communities to help you eliminate a vector is something that is going to be very, very, very difficult. And why is that? It's because at the time when the problem is practically gone, when you've got very few mosquitoes flying around and people do not get bitten, people do not get malaria, then your community is going to shift their interests to other priorities that they are dealing with. And that means that you will have very low levels of infestation in these urban areas. And when the population then withdraws, then your problem is going to come back.
Yeah.
And so for control, that's okay, because then you intensify your control efforts again. But if elimination is going to be your goal, at the end of the day, doing it together with the community is fine, but depending on the community to eliminate only by them is very risky. Thanks.
Thank you. Thank you very much. Thanks a lot, Pat. Sarah? Seth?
Yeah. Okay, so it's
do you still have the other experts?
Yep, who's Fitsum? I know is dropped off. Seth, are you there?
Sarah, is still
I
there?
can comment on this one. I think what distinguishes this urban malaria framework is that it's supposed to be, it's just flipping it on its head. It's not health sector led, it's led by cities, and the health is only one of the sectors that's contributing to that overall response. So this is what's really important about this framework, and I hope it can be implemented in some settings and this approach tested. But what I think we also need to consider is that cities have a lot of things on their plates. They're thinking about equity, poverty, climate change, all these different things that they have to think about. So it would be naive to think that they will spearhead this response when mosquito control is only one of the many health issues they're dealing with, and they've got other things to think about in addition to health. So I think it's going to be a challenge, but I think we need to try and slot this approach into other things that cities are already doing. So we did a study looking at city resilience. So it's Rockefeller funded. They're looking at resilience of cities, and we found they weren't really considering vector-borne diseases as a threat to the resilience of a city. So I think it's really trying to how we as Steve would say, the thin end of the wedge. We try and get in on these other initiatives that are already taking place, so we can have these impacts on mosquitoes as well. But I think it's a challenge because there's many other issues that cities have to deal with.
Do you think that itself is a additional justification to what Bart was saying earlier, that instead of waiting until it becomes a big problem, people should deal with it right now? I mean, if you look at the figures we have, the urban population is going to reach nearly 60% in not so long from now. So if Anopheles stephensi establishes in these cities, even if it's just a minor problem, then you start to have local transmission. And in fact, there was a nice publication here from the isomer groups that indicate that one of the most important things for us to do is to confirm whether there's local transmission in the cities. At the moment, there's not much local transmission in a lot of these urban areas. But if we start to see a lot of local transmission there, then it's going to be really a big challenge, because then you start up to optimize bed nets and stuff like that, and that becomes very expensive for large populations. So would you argue then that maybe there is room to be more considerate to the idea that this is a vector for elimination rather than just regular control?
Yeah, it's a difficult one, isn't it? I don't know which side I'm going to come down on that, but I do agree. I feel like time is of the essence, whichever way we decide to go. Because I just think cities are only getting bigger, and it's not just the number of people in cities, it's unplanned urbanization, basic services not keeping pace, all these other things, around people's living standards. That's a problem to be dealt with, and it's also what's driving this mosquito, I think. So it's a difficult one. I'm not gonna make a firm either way.
Back to you, Nana.
We certainly have to integrate efforts, and with the comment you made, Anne, on the urban malaria, of course, I think we just cannot look at one thing in just one way. We have to work in a more holistic approach, and I think this is the only way we can actually stop people dying of malaria, because it's, at the end of the day, something that can be prevented and treated. So we need to integrate efforts, and it is tough, but much work has to be done. Anyway, back to Anopheles stephensi. So we've learned a lot, but there's so much more that we can learn, and there's so much we can do. And there are lots of open and outstanding questions, and we've put them in here to post them. So that's what is the best way to collect host-seeking adult Anopheles stephensi? How might malaria transmitted by Anopheles stephensi be detected through epidemiological surveillance? How long has Anopheles stephensi been present in Africa, and how quickly is it spreading? What vector control tools existing or in development are most effective in controlling the species? How often are Anopheles stephensi larvae found in the same larval site as Anopheles aegypti? Aedes aegypti, and what might this mean for integrated vector control? So these are lots of outstanding questions that need answers to. And Frederick, I don't think we have time to answer all of these. but then much work.
Yeah, I just noticed that there's an important one missing there, which is what, I know we run out of time here really, but I'm trying to integrate the concerns earlier raised by Abraham and the points raised by Bart. And how do we unionize this? Unionize is probably not the right English word, but how do we avoid a potential future problem that is much bigger than what we have right now, but not necessarily doing so in a way that distracts us from other challenges that, drug resistance, insecticide resistance, current vectors, Gambi, funesters, all that. And I think that's really a missing question here as well. What really do we do? And I don't know, but if I imagine if Fred Soper was sitting in this room today, he would have a very different idea. But I don't know. So it would be nice to hear as we close, Nana, some last words from Abraham, if he's still in the room, and maybe Seth, if you guys can close, and Bart, if you want to chime in as well, and then we draw this to a close. Abraham, are you still there? Abraham probably left. Bart?
Yeah, I'm still here. Thanks for a very interesting few hours. I think what is at the end of all of this, what is still on my mind is the key question: are we going to do it, or are we not going to do it? In the recent few weeks, I've been talking to senior people from very high organizations engaged in malaria. And some are throwing their hands up in the air and saying it's too late, we've lost. This is something that we cannot contain anymore. Others are optimistic, somewhat optimistic. And it's not me, you just mentioned Fred Soper, Fredros. And so if he was here, he would have reminded us of the fact that Aedes aegypti was eliminated over an area of 11 million square kilometers from South America, South and Central America, between 1946 and 1962. He would have thrown that in our face, and he would have said, with all the technology and all of the knowledge, satellite imagery, computers, infrastructure, with everything that you guys have today, which we didn't have back in the old days, you should be able to succeed much better and much more cost efficiently than we were able to do that in the past. Now, the question that is ahead of us now is, again, are we willing to take on the challenge and do it? And if that is the case, then priority number one, and I saw that on the chat, Carlo Costantini made a comment about this should not be taking financial resources away from the things that we are already implementing in other parts of Africa or elsewhere. So this would have to be extra funding that would have to become available to tackle the Stephen's eye problem that we've discussed today. It should be additional funding. And it should be additional funding to the level that we've seen governments coughing up during the COVID times. In my country here in the Netherlands, we spent $80 billion euros in a single year to keep the corporate sector afloat during the COVID outbreak. 80 billion euros for this small little country, the Netherlands. Now let's not go into a direction where we are looking at how can we with piecemeal money try and do this and try and do that. What we need here is highly significant investments from global entities to make this actually work. And as we do this, as we progress with the elimination of Stephen's eye from the Horn of Africa plus Nigeria, we will, as we do that, learn an awful amount on how we are eliminating malaria in the rest of Africa. And let's not forget, many organizations are saying by 2030, latest 2040, it's over. Then we will all celebrate the last case of malaria somewhere in Nigeria. That is 13 years from now, ladies and gentlemen. We better get our act together in how we learn how to eliminate malaria from a single square kilometer somewhere in sub-Saharan Africa. And I think an ideal target would be to start with Stephen's Eye. Let's see how we can tackle Stephen's Eye and learn from that to tackle the rest of Africa when it gets to malaria. Final words. Thank you very much.
Nana, I find it difficult to go after Bat. So do you want to make a comment on that?
I think you should go, Frederick. That was
Yeah,
great.
I think these are very nice words from you. But in the book Gambia in Brazil, they celebrate this by crushing the final insectary of Gambia that they had, by burning it down. And I think that's a celebration that I want to be part of as well. Going into the university and killing the last colony of Anopheles stephensi to celebrate the end of the species. Let's hear last words from all our experts and close this. We're going to start with Delenoso. I can see he's really trying to get a place with Wi-Fi. So final words from all our experts, and then this is really going to be at the end of the masterclass. Delenoso, please. Or any other experts, final words from you. Thank you very much.
Thank you, Frederick, for giving the last opportunity for me. I'm saying that you see the ecological niche or refuge of this invasive species may be different from country to country. That is one really area where we should work intensively when we do surveillance of this exotic species. So right now, what we see as a refuge or ecological niche for this exotic species, especially for adult Anopheles stephensi, is quite different from territory to territory. So we need to focus on that when we do surveillance. And also we need to generate very solid data on its biology, ecology, and behavior. And we should also, as I have mentioned before, we need to actually have an improved surveillance tool, and we need to evaluate also potential candidates, either larvicides or adult intervention tools. So we need to do, we need to do intensively on these areas, and we need to also exchange information so that surveillance and control on this species can be improved much. And this is really the masterclass scheme is very, very important, where experts can exchange their ideas, their expertise, and also the what data they have at hand, and that will really enhance the either control or elimination of these exotic invasive species. So we should keep on this. Thank you very much for organizing this. Thank you.
Pedro, over to you.
Thank you. Thank you to
I think there's an expert. Yeah.
Yeah. Go ahead, Nana.
No, I was going to say, I think there's some more experts to give their last words.
Okay.
Thank you very much, Delenoso.
Who wants to go next? We can finish this in 1 minute, please. Raj, I see you still on the call. Any other experts still on the call, or shall we? Dr. Santa, I see it. Yeah.
Yes.
Thank you so much for giving me the last opportunity. Yes, I would like to say that we have, of course, have had excellent discussion, and thank you very much for organizing it. I just wanted to say in the end that since Aedes aegypti also breeds or co-inhabits Anopheles stephensi in containers in urban areas, and WHO is promoting the use of integrated vector management approach, as much as possible, we should target both species together. Although I know that donors are least interested in supporting control of Aedes, and they are mostly allocating resources for malaria control. But in this case, greater good will be done if both species are targeted together. At least for training purposes, we train people that they can target both species by environmental management or larval source management. Apart from that, of course, WHO stands for supporting technically all the countries, and we are running a program or a project with the help of partners in the Horn of Africa countries. And of course, let us know if you need any information from in the Indian continent, subcontinent. Thank you so much.
Eric, Dr.
Yep. Thanks, Fred. Yeah, for me, I think the two important things. One, we need to continue to study the vector as much as we can, especially as it colonizes new areas. But I agree that we need to move forward with whatever control methods we are aware of. So we know what worked in India. I think let's start doing control where we have identified the vector. Thanks.
Excellent. Excellent. Nana, I think anybody still on the call? Yeah,
Yes,
yeah.
Yes, Fedros, I think.
Go ahead.
Yes. So we have got example, and we have been able to eliminate malaria in a great way in India, and especially the challenge is the urban area, and in the urban setup now going very, very successfully doing. And I am very much sure with Professor Bart that with the existing tools, if we apply properly, I think I am very much sure and very much optimistic that we will to eliminate this species. There's no question on that. There's no doubt in the mind on that. Based on our experience, I'm telling you. I have 42 years experience. I know what to be done on vector control. And regarding Professor Bart, today you are talking of community action. I said that community empowerment is the greatest thing to do it. And still I'm working in many hardcore areas. Community empowerment is very, very important thing. And we had a workshop, I think Tesha was also present in 2018 in Bangalore, and I was the local organizer. I find in Southeast Asia countries, 11 countries, our entomological components are very, very weak. And I don't know other areas, and similar will be there. We have to strengthen our entomological component. Here in India, in Karnataka, with my help, all the entomologists are working day and night, and the success depends on how we are going to train them and how we are going to get work from them. Yeah. And this is the message that we have to strengthen our entomological component. They are the backbone of the program. And we have got existing tool, and very much sure, no doubt on this issue. And I have done larvivorous fish extensively, and it works excellently there. I can tell you about 80 to 90% of the LSM can take by larvivorous fish.
Thank you. Thank you so much. I think that the one group that we missed to acknowledge, and I would really want to spend just 10 seconds to acknowledge them, is our colleagues working on mathematical modeling. I think there are multiple groups here, beginning from the work that was done by Dr. Marian Sinka, excellent support for NNCP programs and also people to get ready. There's additional work that has been done now, adding these sea routes into the conversation and trying to track that. What you see here is just how accurate some of these new analyses are. In fact, Eric, I wanted to just point out that if you look at the projections that were made for Kenya, those are exactly the same areas that you have found Anopheles stephensi in Kenya as an example. So I am very, very happy to see how the contributions that the modeling community, I know Tom was in the call here, Tom Chacha and team. I know that my colleagues in Ifakara are trying to build towards this as well. And we're very grateful for the efforts that our mathematical modelers are putting in these conversations. We didn't have much time to cover in this, but these slides are available for anybody who would like to look at them. The chat will be available for anybody who would like to have access, and of course the YouTube channel as well. And Nana, I cannot end without saying a special thank you to yourself as well for the participation. And I think we should give you the last word to then close the masterclass for everybody. And all our colleagues, please thank you guys so much for joining today. This was an excellent conversation. And sorry for keeping you guys for a very long time. But there was this masterclass for the first time was oversubscribed. We had for nearly 2 hours, 300 people on the call. And as you can see, still, about half of you are still here. So thank you so much for your participation. And we hope to see you in the next masterclass, which will be on February 16th. And on February 16th, we will be reviewing the 2022 World Malaria Report, working with our colleagues at WHO and a few other experts. We will send an announcement for that in due course. Back to you, Nana, and thank you to everybody.
Thank you very much, Fedros. Nothing more to say, but thank you to everyone. And there are more activities also coming on the Anopheles stephensi in terms of trying to create a community of practice around this theme. And there'll be a forum that will be coming up shortly in February. We'll send that through all the social media. You will hear about it. So you can also register. This is more on engaging NMCPs and researchers and different stakeholders on how to start or how to do problem solving. And nothing more to say. Thank you all very much. And especially to the expert and the ease with which they said, okay to join. So it's fantastic.
Thanks. Bye-bye, everybody.
Bye.
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 Bye. Bye. Thank you. Bye-bye.
Thank you. Bye.
Bye.
Yeah. Bye.
Bye-bye.
Bye. Bye.
Bye.
Bye. Bye, everyone.
Bye.
Bye. Bye. Bye. Bye.